Khere. Esteemed participants, welcome to the Technological Innovation in Climate Change Adaptation for Sustainability Forum. It is my privilege to address such a distinguished gathering of visionaries, faculty members, and research scholars dedicated to tackling one of the most pressing challenges of this time, that is climate change. Today, we embark on a journey that transcends traditional boundaries where technology meets sustainability in a powerful alliance. As we face unprecedented environmental shifts, the need for innovation solutions has never been more critical. TICAS 2025 is not just a platform for discussion, it is a furnace for ideas that will define our shared future. Over the next few days, we will learn groundbreaking innovations, exchanging best practices, and participate in meaningful discussions. We shall use the pooled intelligence and imagination in this platform to build paths for sustainable adaptation. Your participation is vital. Each of you bring unique perspectives and expertise that can ignite change. Let us collaborate, challenge conventions, and inspire one another as we work towards a resilient future. Thank you for being here, and let us make TICAS 2025 a landmark event in our shared commitment of sustainability and innovation. Thank you. Thank you all.
Thank you, sir. Now, I would like to request all the participants to please turn on their cameras so that we can take a group picture before starting with the session. So please turn on your cameras. I would like to request all the participants to please turn on your cameras so that we can take a group picture before starting with the session itself. Okay. Now, let's start our first speak of today, Dr. Mukesh Khare, Professor IIT Delhi, an expert in this field. He will talk to us about air pollution science, engineering, and management. Now, I would like to request Dr. Mukesh Khare, sir, to please carry forward the session.
Thank you. And first, I would like to thank the head of the department, Dr. Vanita, for inviting me to share my experience in the area of air quality to the audience, who are mostly from various institutions, including the academic institutions. Thank you, Dr. Vanita, and thank you, Bulana. So my topic of presentation today will be the fundamentals understanding of air pollution, which is a pathway to the sustainable solution. Because when you talk of climate, the climate has two components. One is the global climate, which you see, which works on the basis of higher meteorology from one continent to other continent. The transfer of various types of pollutants, winds, etc. And the other component of the climate is the urban climate, which is at the level of atmospheric boundary layer, where air pollution plays a very important role in impacting the urban scale of the climate, which makes the city vulnerable to various disasters like flooding and heat stresses, and many other climatic effects. So I think the air pollution is therefore very important uh, to study when you want to see that what is the impact of air quality on the urban climate. And in that case, the carbon dioxide plays a very important role at the atmospheric boundary layer. And though the carbon dioxide is not a pollutant, it's a greenhouse gas, but it makes the climatic impacts on the overall meteorology of the city. By sometime it creates the urban heat islands, and sometime it creates the urban carbon dioxide domes, which makes the whole living of the city very difficult in terms of climatic factors. So in order to study that type of climate within the atmospheric boundary layer, it is important to understand the fundamentals of air pollution, which I am going to do today and share my experience of last 45 years in the area of air quality. Next, please. Now, let's first start with a very basic slide, which I have just explained regarding the mega cities. Delhi is one of the mega cities. And like Delhi, there are many mega cities in the world which are experiencing an elevated air pollution levels, which exceed ambient and the health-based air quality standards. And you see that in India, all the mega cities, generally experiences exceedances in the ambient air quality. And it makes the problem of the air quality in a city very critical. And especially the developing countries like India and China, because we are developing fast. A lot of infrastructure development is taking place. So naturally, it produces plenty of pollution in form of gaseous and particulate pollutants. So with this, we need an efficient and effective urban air quality management plan so that we can improve or we can sustain the urban air quality at an acceptable level. Now, to the audience, I would like to say that there are sources which I have given in the slide in form of books and papers. So I would rather suggest the audience who are interested to further know the details to go through these publications, because it is not possible in 1.5 hours to cover everything and to explain everything. But these references are self-explanatory, and I'm sure you will understand the way we have published these.
Sir, the slides are not changing. Please check.
Yeah. No, okay. Is it changing?
No, sir.
Just a moment. Now?
Yes, sir.
Yes, sir.
So this is the first slide which I was explaining to you. So next slide, please. So what are the concerns of air quality, especially with respect to the Indian conditions in metro cities or other urban areas that, in the last 10 years or last decade, the non-attainment cities, number of non-attainment cities are increasing. And today we have 131 cities which are graded under non-attainment cities. When I say non-attainment, it is in terms of pollutants like PM 2.5 and PM 10, the particulate and nitrogen dioxide, and and other pollutants like benzene, and so these pollutants are always exceeding the air quality standards which Central Pollution Control Board has. And most of the sources by which these pollutants are exceeding their limits are vehicular emissions, small and medium scale industries, which are either within the city or surrounding the cities, then generator sets, in most of the cities, because of the intermittent power failure, you have plenty of generator sets, which also emits, pollutants like PM 2.5, PM 10, and other gaseous pollutants. Then solid waste burning, especially during winter season. The urban poor, they use various types of biomass like wood, tire, coconut, used coconuts, etc., to burn and keep themselves warm. That is due to the poverty. These become is one of the very major source for the in the city where a lot of urban poor are there. And road dust, that is another important source which is there in most of the cities. Why? Because we have a tropical climate. The climate is dry, so naturally we go. These road dust becomes resuspended in the atmosphere when the vehicle runs. So that becomes one of the important or major source towards the particulate pollution. Then construction also, because cities are expanding, the urbanization is fast increasing. So a lot of construction activities going on in most of the cities and surrounding the cities area. So that becomes another major source, exceeding the limits of pollutants like particulate and gases. And the last, major source is the landfill emissions, especially for the metro cities, where a number of landfills exist, from where the gases like methane, etc., which is also a greenhouse gas, they are emitted. So these are the very dominant sources for any city in India. As far as air quality exceedances are concerned, these are episodic, and most of the metro cities, like especially Delhi, it experiences these exceedances in an episodic
slide is
manner.
not moving.
Is it moving?
Yes, sir, it is moving now.
Yes, sir. Now it's okay.
Okay. So the next bullet, if you see in the slide, is exceedances, especially for Delhi, city like Delhi, where stubble burning takes place, and many pollutants, they find its way to the atmosphere of Delhi when the wind velocity is towards Delhi from those areas where stubbles are burnt. And the last is the thermal power plant, especially those plants which are using coal. That also became one of the major sources. So the major concern, the next bullet in this slide you can see, is that how to tackle these sources, how to make these sources manage so that the pollution, we can reduce the pollution. In order to do that, there should be a connection between the policies, technology, and governance. Unfortunately, in India, most of the cities, especially the metro cities, there is a big disconnect between technology, policies, and the governance at all levels: national level, state level, and local levels. So that has to be filled up, that has to be solved, so that we can have a proper communication between the national level, state level, and local levels to make the governance more effective. Next, please. Now, let's start with a very basic questions of air pollution and what are the pollutants which are making our life difficult living in the cities. Next, please. So first, let us understand the atmosphere. I think most of you people must be knowing that atmosphere is divided into various smaller layers based on the temperature variations, and the lowest layer where we live is the troposphere, where most of these air quality studies are done in the troposphere. But
Still, the slides are not moving, sir. Sorry to interrupt you.
No, we are not moving. Now, can you see this slide? Because I'm on this slide. Slide
Which
number
slide,
5.
sir? No,
Slide number
we are
5.
on 3. We can see only 3. Slide number 3.
Yeah, all right. Why it is not moving? Let me do it again.
Yes, please. Probably you can put in a presentation mode, enlarged mode. The down funnel.
Is it moving?
No.
No, sir.
Yeah, all right.
No, sir, slide number 5 is fixed on the screen.
In 6, can you see 6?
Yeah.
7,
Yes.
8.
Yep.
Okay, let's go back to 6. So, this I would like to say that the troposphere.
Can you throw one, sir? We missed that slide, the previous slide. Okay, fine. Let's go ahead, sir.
Right.
Thank you.
So when we study air quality, we study, the lowest about half a kilometer of the troposphere, where all the turbulence and air quality studies are done, because this half a kilometer, about 500-meter layer from the surface of the Earth, can be simulated and can be studied very easily, either in wind tunnels or by measurements by various instruments, including the satellite measurements. So there, most of the air quality or air pollution takes place. So next, please. So first, we have to see that what is air pollution. When we say that we study air pollution in the troposphere, then we have to see that we have to understand that how we can define air pollution, what we study in the air pollution. So let's first define the air pollution. And this definition, which I have just given over here, is the adopted by the OECD countries, that is the Organization of Economic and Cooperation, Organization of Economic Cooperation and Developing Nations. From the and it has been taken from the United Nations Conference, which held on 5th June 1972.
So probably, I'm sorry to interrupt you, Professor. Still, it's not moving. Next one. I think you are, yeah. Now we saw it.
So I think if in full screen mode, it's not moving, but if it's not full screen mode, then it is moving. Is it visible? Is it visible?
Yes. Yes, sir.
Okay. So I'll keep on this mode only, because when we go for the presentation mode, it doesn't move.
Fine, sir. Yeah.
Okay. So this definition of air pollution is adopted by the OECD countries, and this definition evolved during the United Nations Conference on 5th June 1972, which we generally celebrate as the Environment Day. Now, if you see this definition, it has a very clear meaning that how we can define the air pollution. And all these bold words which I have put on the board is very important for you. And most of these words which are in bolded form, they are open-ended. Say, for harmful natural and synthetic materials into the atmosphere as a direct or indirect consequence of human activity, which can affect the health of living or non-living things. So these open-ended words, has been kept by the United Nations, so that each and every country, can define these open-ended words. Say, harmful, what is the standard? India has different standard, and Pakistan has different standard. Bangladesh has different standards, depending upon their resources, depending upon the money available, depending upon the instruments available. They define their own standards and guidelines. And both natural and synthetic materials have been covered into that is natural pollutant as well as the man-made pollutants. And both the activities, like the pollutants which are generated through direct activities, say for example you are driving car, or you are producing power from thermal power plant. So these are the direct activities. And indirect activities which
I'm not sure if you're not audible, sir.
is it audible now?
Yeah, it is.
I think it's due to the internet. I think that's what I feel. So anyway, the indirect activity of the air pollution is the creating large dams. As I was telling, large dams have a large reservoir. So large reservoir will have a lot of organic matter which settles down on the bottom of the reservoir, and then they are degraded over there. And when the degradation takes place, the greenhouse gas like methane and S2, hydrogen sulfide, etc., they are emitted from that reservoirs. So it is a consequence of indirect activity which creates air pollution. And we only included the human activity, as you see in the definition, and no activity by animals, etc., because we human have created imbalance in the ecological sphere of the earth, which created different types of pollutants, including the air pollution. And also the effect which we study is on the health of living or non-living beings. So living beings is the humans, and non-living beings is the buildings, materials. These are the various non-living beings where we study that how these pollutants impacts, how this pollutant affects those materials. So this is the official definition of the air pollution adopted by OECD countries, and based on this definition, the countries have worked right from 1972 in order to frame their laws, standards, etc. Now, with this, next is what is the air pollutants? What are the air pollutants? How we define it? So the air pollutants are those chemicals which cause pollution of the air, and they occur as a result of either anthropogenic activities or natural activities. And the types of air pollution, if you see, I have put here personal air pollution, which is due to the cigarette smoking, which occupational air pollution, which is due to the occupation. Say, for example, anybody who is working in the occupation like coal mines, and within the coal mines, whatever the pollution is generated, it's an occupational air pollution, and that is a different way of control and different way of management. And the third is a community air pollution. So we, as an engineer, we generally work for the management of the community air pollution. When I say urban air quality management, it is related to the community air pollution. That is the ambient air pollution by the different types of sources. Next, please. Now you can see this slide number 7. Can you see the slide number 7? Okay.
Yes, sir. Thank you.
Now, as I was explaining the definition, which is adopted by OECD countries, we have to work upon it. Every country has to work upon it. And in order to work upon it, that is, when I say work upon it, it means that creating standards, making guidelines, evolving the method of monitoring, etc. It means that we have to make this definition into systems approach. And this is the chart which which defines that particular definition adopted by OECD country into a systems form. So, for example, there are 5 boxes here. On the left side box is called sources of air pollution, right? Which is first box. Here you have to identify the sources first. What are the sources of air pollution? Whether the sources are a line source or point source or area source. So that has to be identified and quantified, both, by any means, either by by the fixed instrumentation or by the mobile instrumentation, or by the remote sensing. You have to quantify those sources. So the first box that has to be first tackled. The next box on the right hand side is the meteorology and topography, because meteorology affects the emission from these sources. And when I say meteorology, you have to measure the wind velocity, wind direction. You have to measure the solar radiations. You have to measure the pressure, ambient temperature, etc. Well, all these parameters affects the dispersion and diffusion of the air pollutant emanating from different types of sources. So these 2 boxes, they are related to each other. They join each other, as you see over here, and which gives or which results in giving you the air quality. If wind velocity is high, then it means the dilution will be fast. So air quality will be different. If wind velocity is very low, like it happens during the winters, the air quality will be different. So that gives you the air quality. And there this line which is joining these 2 boxes to air quality, this line is to be quantified using different types of air quality model, which which analyze the dispersion of the pollutant from the sources, and which gives the air quality in terms of the ambient concentration. So, and this when you get the air quality, then that air quality has to be studied in terms of effects on the receptor. That how this type of how this quantified air pollutant, whether it's SO2 or NO2 or particulates, which has been quantified in terms of microgram or gram per meter cube or microgram per meter cube, how it is going to affect the receptor where the pollutants are reaching. And receptors may be humans, or it may be non-humans like trees or buildings or materials. And when you there are various methods of studying these effects of the air pollutants on these living and non-living being, either by the chambers method, if you want to analyze the effect on the plants, then chamber studies are being done. And if you want to analyze the effect on the humans, then epidemiologists also will come into a group, and they generally study either by the questionnaires or by the direct experimentation, by taking blood samples, by taking the hair samples, and many other methods are available to study the effects. Once you see the effects, and if the effects are positive or effects are negative of the air pollution, this depends upon that what is the quantity, what is the air quality, then you have to plan the control. And the control either at the source or control at the receptor level, right? So these control has to be planned by the depending upon the effects on the receptor. So this is the definition based on the systems approach, which makes you or which gives you a direction that how the air pollution has to be studied in any ambient atmosphere. Next, please. Now, this slide number 8 over here. Can you see this slide?
Yes, sir.
Okay. So this slide tells you, once we define the air pollution, as a systems approach, then we have to, you see the first box, we have to see the sources. Now, based on this first box, now this slide is completely directed towards the city of Delhi and Delhi NCR, where we studied the different types of sources. We quantified different types of sources. And if you see on the bottom of this slide, it is written over there that total nation level studies on source apportionment and emission inventory, which has taken place in the country, is 14. Based on these 14 studies at different institutions, these sources have been identified. Not only in Delhi, but in most of the metro cities of India. And these are the major sources, except one source which has been in the yellow color, if you see, is agricultural residue burning in surrounding rural areas. That is specific to the Delhi city, not to other cities. Otherwise, most other sources are common for most of the cities. And in that, the motorized traffic, the industrial emissions, open biomass burning, these are the major sources, along with the resuspension of road dust and the transport of dust from surrounding areas. So that is already identified by air pollution sources. Next, please. Now, among all these sources, the major sources which are responsible for making our ambient air quality bad in urban areas is that these in blue box, these are the major sources. That is resuspension of the road dust, construction dust, waste burning, transport, the diesel generator sets, industries, and domestic cooking. Now, this percentage which you see over here is specifically for Delhi cities. And because most of this, a lot of studies have been done for Delhi NCR, and we have found that these are the various percentage of contribution of the PM, especially for the PM, not for gases, only particulate matter, because our air quality index is majorly calculated based on the particulate matter. So these are the major sources for the PM, that is 2.5 micron size PM and the 10 micron size PM, which is the most critical pollutants. Next, please. Now, once we identified the sources, then we have to find that why these sources are causing the urban air pollution. What are the causes? What are the reason behind that? These are the 4 bullets which I have explained to you. One is the uncontrolled sources, that is sources which are not controlled. If there are point source and if their controls are there but they are not working properly, say for example thermal power plant, ESP is there but ESP is not maintained properly, it's not working properly, so we categorize under uncontrolled sources, right? So that is one of the cause of air pollution from these sources, that they are not managed properly. Second is unaccounted sources. That's those sources which has not been quantified. Say, for example, resuspension of road dust. We don't have any quantification that how much this type of road, that is the service road or major roads. Say, for example, in Delhi, we have ring road. Then we have service roads. Then we have, other small lanes. We have not quantified that how much road is resuspended, if the public is working on that or vehicles are moving on those roads, how much resuspension is there. So that type of sources will be categorized under the unaccounted sources. Another unaccounted source is the biomass burning, which has not been quantified till today, that how much pollution, that particulate is generated from the burning of the wood or burning of the all other materials like coconut shelf. And in Delhi, a lot of coconut shelf if you go towards the East Delhi, they burned it during the winter. So these are and cow dung, that also is one of the other source which is burnt or which is used by the urban poor. So these are not accounted. We have not quantified that how much emission is coming out of that, and how much in that emission, how much particulate, how much gases are coming, that is not being quantified. So these are categorized under the unaccounted sources. The third is the geographic location is very important. Say, for example, in Delhi, if you see the geographic location, is very peculiar geography is there of the Delhi, because on one side, on northern side, there's the Himalayas, and on the southern side, southwest side, there's a Aravallis districts. So these two, mountain range, they make the Delhi in a very peculiar topography, which makes the pollutant coming from other cities, and then it is stagnated over the atmosphere of Delhi. So geographic location is very important, which is an important factor. And unfortunately, we cannot control the geographic location. We cannot change the geographic location. So we have to only control the sources so that the pollution can be reduced. And the last is the meteorology, which is a driving force of bringing the pollutants from other areas and other cities to the receptor site. So these are the 4 causes of urban air pollution for any city or any urban area. Next, please. Now, this is slide number 11. I hope that you are seeing this slide. Now, this slide just tells you the National Ambient Air Quality Standards, which are revised in 2009. And another committee has been set up now about a year back, under the chairmanship of the Central Pollution Control Board. And we are, another re-revision is being done of the standards, depending upon the, its relation to the health of the receptors. So that is, the committee has been set up with the IIT Kanpur, IIT Delhi, IIT Bombay, NEERI, and many other institutions. But at the moment, the 2009 standards, we are following these standards, and these are the pollutants which are covered in that standard. Next, please. Now, let's start discussing what are the classification of air pollution sources. As I told you in the beginning, there are 3 types of sources. Point source, which is a stack type of, it's called point source, which emits gases and particulates. Line source, a roadway with a number of vehicles plying on either directions, called line source, because these vehicles, they ply in a line, so they become a line source. An area source is a settlement, colonies, stubble burning, open storage of sand, silt, cement, etc. These are the area sources. So these are the major classification of air pollution sources, and these classification are studied by different types of monitoring protocol and modeling protocol. Next, please. Now, another important thing which you have to understand is the difference between the pollutants and contaminant. Pollutants are man-made, which is present in the material form. It may be gaseous form, it may be particulate form, but it's man-made. And contaminants are naturally occurred. So, for example, if any volcanic emission comes, or there is a forest fire, these are the and pollutants coming out of those sources which are naturally occurring. They are called the contaminants. And it may be in the energy form or it may be in the material form. Next, please. Now, when you say pollutants as a man-made pollutant, there are two types of pollutant, primary and secondary. And primary pollutants are directly emitted from sources, as I have listed over here. Some of the examples of primary pollutant. And secondary pollutants, they form in the atmosphere when the primary pollutants, they react with each other, or they react with any other gases present in the atmosphere. Say, for example, acid mist, acid fumes, photochemical smoke, ozone, these are all secondary pollutants because they are formed as a result of reactions between different types of primary gases and particulates. Next, please. Now, as I said, our critical pollutants for India or most of the cities in India is the respirable particulate matter, because we are having a tropical climate, dry climate. So we have a lot of dust in most of the cities. And the dust is especially respirable nature. And when I say respirable, it is PM10. It goes up to throat or nasal, links of throat. It doesn't cross your lungs, so that is called respirable. Inhalable, and those particles which crosses lung sac is called the respirable. So PM10 and PM2.5 are the major pollutants which are studied in various by various institutions here. And these respirable particles or inhalable particles further classified into fine particles and coarse particles. When we say fine particles, it is 2.5 and below. And coarse form of particles between 2.5 and 10 micron. These are the coarse form. And corresponding sources is listed over here. Say, for example, crushing, it produces coarse particles. Combustion materials, it produces fine particles, 2.5 and below. Right? So that sort of classification of the particles are there. Next, please. How to manage these particle and or gases pollutants? This is the urban air quality management that we follow. And this has been, created by our group in IIT Delhi. And most of the work is being done by various institutions, including Central Pollution Control Board and other institutions based on these boxes, which is clearly mentioned over here. And we have numbered the boxes, where you want to start and where it is ends, right? So I don't have to explain the whole box over here, but if you want to know the details of this management process, this book is quite good, which you can refer to, written by our group here from IIT Delhi, recently published. So it explains in each and every boxes that how we start with that. But the major explanation of this box is that we start with the monitoring of pollutants and meteorological monitoring. Then we go for emission inventory. Then we identify the sources. This is as per the definition which we have already explained to you in earlier slides. Once sources are identified, then we go for the predictions, that dispersion, so to know that how much pollutant from source is reaching to the receptor, right? Once it is quantified, then we develop and implement the cost-effective action plan to control, where we also engage the public and the stakeholder. And once the cost-effective action plan is, that is number 4 box here, is evolved, then we go for the checking whether the air quality standards from those action plan is achieved or not achieved. Depending upon that, we take the decision. If it is achieved, then we ensure the enforcement of that particular action plan, as you see from the dotted line over here, and then evaluate the effectiveness of the action plan. So that is the whole urban air quality management, which we are generally doing presently in India. Next, please. These are the various levels at which these urban air quality management plans. Sorry? Yeah, anybody want to ask something? Hello?
I request the participants to mute themselves, please.
I think it's something is somebody speaking. Anyway, so this management plan, which I have just shown to you, is only workable at the local level, which I have because urban air quality management at different levels. If we can see over here, I am only we are only concentrating on the local level here, or up to regional level, not national or international level. Because once you control or manage the air pollution at local or regional level, right? So you can divide the country to various regions, various localized communities where you can manage the pollution, and that the way you can control the whole air quality at the nation level. So our interest is restricted to the local and the regional level here, for which this urban air quality management framework, which I have just shown you, is applicable. Next, please. Now, as far as the local air quality management plan, when I say local, it is essential because it avoids unnecessary regulations and it also promotes clarity and consistency and certainty that, okay, if we apply this action plan, we will certainly going to get results. So local level air quality management is very essential to secure improvements in the most cost-effective, economical manner, because economics we have to take care of how much cost-effective the action plan is. So for that, the local air quality management plan has to be evolved so that we can have a cost-effective action plans and control measures for that. And details of this LAQM, which we have devised for Delhi city, you can find in this reference which I have given on the bottom part of the slide, which you can, and it is self-explanatory publication which we have done, back in 2007. Next, please. Another sort of at the local level, there is an episodic urban air quality management plan, which is also very important. Some episodes may happen. Say, for example, a stubble burning. It is the pollution is being transported from various cities surrounding the Delhi to during the winters. How to manage that episode? And that episode is for short period, right? Say, for example, a week, for 12 days. Not for 2 months or 3 months, right? So that episodes has to be managed by different management plan, right? And these episodes results into the exceedances of the pollutant above the standards, and exceedances are very heavy, actually very high exceedances, very large exceedances takes place, and that exceedances makes the local area into hotspots, right? So we have to classify air quality in terms of the hotspot, and that can only be done by or managed by the episodic urban air quality management plan. And this episodic urban air quality management plan was evolved, and which you can see the details from these references again in 2007, by this publication, where we have very clearly explained, and a framework has been made for the episodes for the city of Delhi, and the hotspot which we have taken is the ITO intersection. There is a big intersection called Income Tax Office intersection in Delhi, for which this framework was designed. So that is another important management plan, which is at the local level, but episodes for the hotspot. Next, please. Now, once we have these management plan with us, then in order to act those management plan, we have to have a air quality data, and for the data we have to go for the monitoring. And so why we do for the monitoring? To know the contaminants, from where the contaminants are coming, what are their concentration, and what are their characterization, whether they are gaseous, whether they are particulates. If they are particulates, what is the size of the particles, 2.5 or 10, right? So these are the reason that we go for a proper monitoring or sampling plan for any hotspot. Next, please. So what is different between monitoring and sampling? The monitoring is automation, that is, we have a automatic data concentration on the instrument itself, while the sampling is a small portion of air that represents a large entity. So, for example, in this figure, it is very clear that you have a population or large population here, and then you take small sample, as I show you the next circle, in the 3 dots, 2 reds and 1 blue. There is a sample which represents this, the large population. So a sample of air in a bag having definite volume is a representative of a portion of the air mass that we want to study. So this is the definition of the sample. Next, please. Now, this is a difference I have explained to you, that monitoring and sampling difference. Sampling is done on the site, which is a gravimetric or absorption collection of contaminants, while monitoring is automatic continuous analysis of the samples using various type of methods like infrared, chemiluminescence based techniques. And various instruments are being designed based on these principles. Next, please. Now, when we do sampling, as we do in the air quality, we use high volume samplers. There we take the samples. Then we have to decide the frequency and number of samples so that our representativeness should be maintained. Now, the frequency and number of samples, as I've explained here, it depends upon the airshed under the study. When I say airshed, is the area which you are studying for the air quality. Say, for example, it's a New York City, a very big city, a large airshed, while Port of Spain in West Indies or in any other country is very small country, a small airshed. So type of site and contaminants, it depends that what type of city you are dealing with. If a high toxic contaminants are, if you want to analyze, then you have to take more samples. Then you can have accuracy can be maintained. And critical sites have to be covered, like national parks and hazardous sites has to be covered also, so that more samples to be there. So it means, in a nutshell, the frequency and number of samples depends upon the size of airshed as well as the type of site and contaminant. Next, please. Now, representativeness of the sample depends upon the environmental media. If, say, for example, if the lake is very large, or if the airshed is very large, and you take only one sample, you put the high volume sampler, or if you take 1 billion liters of water and take the only 500 milliliter of water from the lake, or you just keep high volume sampler at one place in a large city, that sample will not be a representative. So it means that you have to have more number of samples, either it's water or it's air. You have to take more number of samples so that the samples can become a representative. Next, please. So that's the slide which explained that in a given example, that how you make the sample representative, so that your accuracy can be maintained. Next, please. Again, this is a continue to explain that how the representativeness of the sample is maintained. Same you follow for the air quality as well. Next, please. Now, there are different forms of sample, like grab, composite, and multiple composite. And now, grab samples at single site at one time. This is only required to know whether the pollution is there or not. once you are sure that with the grab sample you found the area is polluted, then you go for the more in-depth study, sampling. So in that case, you go for the composite samples, from different locations, and then, or if you want to have a more accuracy, you go for the multiple composite sample. That is, you take the samples and then you physically, mix the various composite sample to each other so that you can have an average, physical averaging of the samples can be done. Next, please. Now, next is the frequency of data collection. That was very important. For the gaseous pollutant, we go for the continuous monitoring, and for the particulate pollutant, as per the Central Pollution Control Board or National Ambient Monitoring Program, we go for the once every 3 days. That is the guideline given under the NAMP program for the particulates. Next, please. There are various ambient air pollution monitoring equipments, which I would show you next slide, which are available for monitoring the air quality. Next, please. So the most commonly used instruments are on the left-hand side is the respirable dust particulates, and the right-hand side is the PM2.5 sampler, which gives only PM2.5. Next, please. There is a NOx monitor and a SOx monitor, which most of the institutes have got for the, at most of the sites, these type of instruments are kept at this monitoring sites. Next, please. This is a GRIM aerosol spectrometer, which is a laser-based spectrometer, which gives the direct reading of 2.5, PM10, and PM1 particle size. And right-hand side is the weather monitor, because every monitoring stations, should have a weather monitor, at least, so that we can have a micrometeorological data with you. Next, please. This is a CO monitor that is only for those areas where a lot of vehicle density or vehicle population is there. Then we keep the carbon monoxide monitor, because CO is mainly emitted from the vehicular exhaust. Next, please. Now, these are different types of ambient monitoring stations, and these are given by the WHO. These are the various station type. These are the types have been defined on the right-hand side. They're what as a type A, type B, type C, type D, type B, and type F. Say, for example, type F, if you see, it is defined by WHO as a specialized source survey station. That is, to determine the impact on air quality at specified location by an air pollution source under scrutiny. So, say, for example, Taj Mahal is a type under the type F station, was a specialized source survey station, which is studying the Mathura refinery, that how Mathura refinery emissions are reaching to the Taj Mahal site, and how it is, and how much and what is the effect of those emissions coming from Mathura refinery affecting the marble. So it is under the type F. So in that way, if you read this station type, WHO has given the guidelines. It is just a guideline, and many countries establish the station depending upon these guidelines. Next, please. Meteorological monitoring is mainly done with respect to the primary meteorological parameters, which are required for any modeling studies, say wind speed, wind direction, humidity, and temperature. We have to monitor these four, because these are the primary meteorological parameters which are required for analyzing any dispersion of pollutant from any source. Cloud cover, pressure, and precipitation, they are not required by all the models, but certain very specialized model, air quality models, they require these data as an input to run those models. The secondary meteorological parameters are in form of visibility, ceiling height, solar radiations, albedo, and upper air meteorological data. Say, for example, air mod. This is one of the commercial models based on the Gaussian principle. It required these type of secondary meteorological parameters also. But ADMS, another model, which is by Trinity, UK. It doesn't require the secondary meteorological parameter. It requires only primary meteorological parameter. So it depends upon the model, that what type of model you are using. Next, please. These are the weather stations, just a pictorial view of the weather stations and different component, parts of the weather station, which I have mentioned over here. Next, please. This is one of the windrows diagrams, which are invariably used in air quality studies. And you have to draw the windrows diagram. It is better that you, for any receptor site or any source site, it is better that you have a micrometeorological data, and then you draw the windrows diagram. But if you don't have the micrometeorological data, then you can go for the meteorological station which is nearest to that particular site, and then you assume that the same type of wind conditions are existing at your site, and then you can use these windrows diagrams, which gives you the predominant wind direction as well as the wind speed corresponding to that wind directions. So, for example, in this windrows diagram, the wind is from south to north. Next, please. Another important input to the air quality models is the emission inventory, which is the which is in form of load of the source. That is, what is the source quantification and the source itself. And the unit of this emission inventory is the grams per second. That how much grams of sulfur dioxide is emitted if you burn 1 kg of the coal, something like that. So you have to have emission inventory for different sources. So, for example, if you are running diesel car, that how much NOx is emitted if the car is run for 1 kilometer, right? So this type of emission inventory has to be done for different types of sources which are there in the city, and which is very important for the dispersion or modeled analysis. Unfortunately, we don't have emission inventory for all the cities. We have quite a good emission inventory for Delhi and NCR. But if you ask that if Bangalore is having emission inventory or Visakhapatnam is having emission inventory, and unfortunately we don't have detailed emission inventory for these cities. So I think this is one of the lacuna of our models which are not working properly, where the emission inventory is not available. And even for Delhi NCR, we have emission inventory of 2018, when TERI has done a very comprehensive exercise for the emission inventory, but these emission inventory has not been updated. And you know that sources are changing because our country is progressing fast. Delhi is urbanizing fast, so sources are changing. So these emission inventory has to be updated. So, for example, in US, we have AP42 document, which gives the emission inventory of all sources. And this AP42 document in US is updated, I think, every 3 years, if I'm not wrong, or every 4 years. It is updated there by US EPA. That sort of protocol should be maintained for India if we want to have a good prediction, accurate prediction for the pollution. And without prediction accurate, the management is not proper management. Effective and efficient management is not possible. Because we should know that how much concentration or how much emission will be there after 3 days. That requires a good model and good accurate emission inventory data as an input to that particular model. Unfortunately, we don't have at the moment, and we have to work a lot in this area so that, especially the CPCB has to make a protocol for an effective and efficient emission inventory protocol. Next, please. This is the chart which tell you the why EI is needed, and I have explained many of these, that it's a major input parameter and is helpful in deciding the control strategies and also models. It needs accurate data for the models as an input, and also it is used to indicate type of sampling network and location of monitoring station. But if you have an emission data, that what type of if emission data from vehicular emissions and major source, then the sampling network will be different. If you have emission major source is thermal power plant, a point source, then sampling network or monitoring network will be different. So AI also help you in making decisions that what type of network you should develop for that particular area, sampling or monitoring network. So it's very important parameter for prediction as well as for designing control strategies and designing the sampling and monitoring networks. Next, please. This is the slide which tells you how the EI is done, how we do. So, though to do EI is quite a comprehensive and quite a it needs a lot of resources and manpower, but it is an important parameter. So we have to be have a proper protocol for this emission inventory technique. So these, say for example, in this first list the type of sources for the study area. Second will be determine the type of air pollutant from each source, that from which emission is coming from these sources. Then third is examine the literature to find out valid emission factors. What are the emission factors that if this source is suppose there are car is a major source, or buses are the major source, or trucks are the major source, different types of sources are there, then what is the activity of those sources, how much miles or how much kilometers they are running, so whether it is a urban area or it is a periphery of the city. So depending upon the central district or periphery, the emissions will be different. So these type of things you have to design and then find out what is the emission from different types of activities of those sources. Then next box is number 4 is determine the number and size of specific sources, and how many numbers of buses, how many numbers of cars, how many numbers of two-wheelers or three-wheelers. All these emissions have to be taken. Data has to be taken. That's why I'm saying it's quite resource intensive. You have to have a proper planning to know the emission from each source. And the last is to multiply the appropriate numbers from 3 and 4 to obtain the total emissions, and then sum the similar emissions to obtain the total of the area. So 3 and 4 is very important, that once you have the data from number 3 and number 4, you multiply, and then once you get this emission, then you do the sum of all these emissions of that particular total area. And for each source, you have to do this type of exercise. So this is quite a comprehensive technique which emission inventory has to be done. Next, please. Once you have an emission with you, then you can go for the model, that is prediction. And what is model? When you say air quality model, this simple chart tells you the definition of the air model. There's a real world problem. You formulate the real world problem using some mathematics, and then you have a formulation, and then you solve that mathematical equations, and then you interpret in form of the real world problem. So interpretation and formulation, these are the most important exercise, major exercise in any process of air quality modeling. Next, please. So here the definition of a mathematical model is explained over here. That is the relationship between emissions, that is the source load grams per second, to the air quality, which is microgram per meter cube. So it is a relation between emission and concentration. And it also the model evaluate the different emission control strategies under what if scenario. What if scenario means what is the pollution if this is the source, if this is the emission, what would be the pollutants? That is called what if scenario. Next, please. So in order to go for the mathematical modeling, we have to have a systems approach, follow the systems approach, which has been described in this figure. That emission, you know that through emission inventory. Then you know the proper mathematical model, whether you want to do the statistical model or deterministic model or numerical model. So depending upon the type of the model, emission will become an input to that. Meteorology also become one of the input parameters which you feed into the mathematical model. And so there are some additional model input parameters which you have to feed into that. So for example, topography is one of the additional input parameters, hilly area, urban area, rural area. So that coefficients you have to put into the mathematical model of the different type of topography. And once you have this model uses those parameters and then come out with a concentration which is in form of air quality. So this is the definition of the air quality model in terms of the systems approach, that how we do it. Now, emission quantified, meteorology, you know, by measurements, model input parameter depending upon the type of the topography, and you have the coefficients either from literature, because these are urban area, semi-urban area, rural area, the coefficients have already been evolved. So use those input parameters to the mathematical model, and these mathematical models solve these equations and then come out with the air quality, which is in the form of the concentration, and the unit of concentration is the microgram per meter cube. Next, please. Now, once you have the model, then there are different, as I said, it may be a different types of model. Deterministic model, which is one-to-one relationship. That is, what is the cause? This is the source, that would be the cause. This is called deterministic model. If the source is, vehicles, the cause will be carbon monoxide. If the source is thermal power plant, the cause will be sulfur dioxide. Something like that. So it's a direct relationship between the source and the cause. Then statistical model, they are very useful for short-term prediction, because statistical model are data-based. It is good for the very, very short-term predictions. So if you want to know the prediction of between 8 a.m. to 10 a.m. from the vehicle air pollution, when the lot of vehicles come because of the office hours, people go to the office, so the vehicle density becomes very high. And if you go for 12 to 3, then vehicle density becomes very, not very high, very low vehicle density. Then again from 4 to 7, vehicle density become very high. So this, diagonal variation in the vehicle density will make the pollution different. So any deterministic model cannot deal with this type of, variations, because during 3 hours, the concentration of carbon monoxide or concentration of nitrogen dioxide or particles will be very high in the morning. Similarly, in the evening also very high, but in the afternoon, it won't be very high. So in order to predict or forecast the morning hours or evening hours, you have to go for the statistical model. For deterministic model, generally average it out, because it goes for a whole day. It don't go for the short-term predictions. So in that case, you have to go for the statistical model. And physical model is generally by using the wind tunnels, where we simulate by creating the scale down models in the type of a wind tunnel, which is a big laboratory, where we create models of vehicles, models of buildings, models of trees, and then we keep on the turntable, and then we release the wind from a fan, and then we take the samples. When we release the tracer gases over there, we take the samples. So this is called the physical modeling technique. IIT Delhi is having the physical wind tunnels over here, and it is an environmental wind tunnel which we have in our applied mechanics department, and we have done quite a good number of projects where we simulated many areas of Delhi inside in the tunnel, and then we have studied what would be the dispersion, how if this is the vehicle density, if this is the if the flyover is made, then how it is going to make difference in the concentration of the pollutants. So that is it's quite good to do experiments, but it's very expensive. To maintain the wind tunnel is quite expensive, and in India, the environmental wind tunnel, IIT Delhi is only having. No other IIT is having the environmental wind tunnel where we can, create or we can study the pollution at a very low wind velocity. That is from varying from 1 meter per second to the 3 meter per second. Other wind tunnels which having in India, like in IIT Roorkee or in the Bangalore, they are very high speed wind tunnels, where we can study the wind effects on the buildings, on the structures, where the high wind comes, then how the building is going to behave, or in National Aeronautic Laboratory, where the planes are being, jet planes, etc. They are designed, they are all tested in the high speed wind tunnels. But environmental wind tunnels only IIT Delhi is having. Now, going ahead with the deterministic model, there are two types of model, if you can see in the chart: steady state and time dependent. Statistical model are the regression model and empirical model, and physical model is the wind tunnel simulations. And if you go again to in the tree, the steady state model is the Gaussian plume model, which is quite a simple model, and it has been used invariably for any prediction, like air mod, ADMS. These are all Gaussian based model because they are very simple, and their the CPU time is quite low, right? And the predictions are quite accurate, though there are a lot of assumptions which we in the slides ahead will study in detail. Time dependent model, which is unsteady state model. There are with various types of model. I have defined box, grid, spectral, puff, and trajectory model, and with different frame of reference like Eulerian and Lagrangian. And if you want to go into detail, I know that it's very difficult to explain everything in the hour which is allotted to me. But I would suggest that those who are interested in air quality model, they should study this book, where I have explained, in a very simple language and examples that what are these models are and how they are work. And Weber also is a good book to see that different types of models and their characteristics. Next, please. Now, this is the equation for the deterministic based model. Again, that book will explain you how these equations have been used and how it is being evolved. Actually, this equation is they are evolved based on the Fick's law of diffusion. Fick's law is the basic law, right, which explains the diffusion. So all the air quality model which are Gaussian based is based on the Fick's law. So so this equation have been derived based on this, and you can see in that reference that how the delta C over delta T on the left hand side, which is a air quality, which is concentration, depending upon the time, and the first on the right hand side, the first expression, which is U del C over del X, V del C over del Y, and W del C over del Z, is advection, which is a transport, and the other variables which you see over here with KH, K, and KZ, it is the diffusion, which is a second moment of the concentration in X, Y, and Z direction. Q is the source term, which emission, which I have already talked, and R is the receptor term. That is where the pollutants are synced, where the pollutants are deposited. That's called R. So this is a general equation of deterministic-based air quality model. And based on this equation, the air mod and ADMS and many commercial models are being used based on this equation with assumptions. Because there is general equation, but all the models, they use this equation, but they, for example, air mod, it doesn't take into account R. Only they take Q under certain assumptions. Because it assumes that the pollutants do not settle on the ground. It always remains in the atmosphere. That assumption it does. And that's a Gaussian assumption. Next, please. The mostly used deterministic-based air quality model is Gaussian, which I have already described to you. Next. And these are the assumptions which I was just explaining to you. And if you see over here, pollutant reaching the ground, yeah, this is the one. There's 1, 2, 3, 4. Fourth assumption bullet, if you see, very clearly written that pollutant reaching the ground level, that is at R, is reflected back into the atmosphere. That is assumption. That it never settles down. It reflects back. So that's why the Gaussian-based model, it gives very conservative results. The prediction is higher than the observation. That's what I mean to say. When I say conservative results, the prediction by the Gaussian-based model is always higher than the observed data. That is the observations where the instrument has been kept. Because it assumes that all the pollutants come back to the atmosphere. While in reality, it is not. In reality, some pollutant settles down. Right? So that is why Gaussian models are quite conservative. And why it is popular then? Because the regulators, they are happy, they are safe. Because they say, okay, if the prediction is say 200 microgram per meter cube, while in the observed data is saying no, it is 100 microgram per meter cube. But the regulator will say to the polluters that no, you have to work with the prediction which I have got. So you have to go for extra, management of the pollutant, extra control of the pollutants. So it is good for the regulator, safe for the regulators, but expensive for the polluters. Because unnecessarily they have to take extra steps, extra management steps, extra control steps to control that 200 microgram per meter cube, which they are not polluting. Right? So it is, that's what I shouldn't say that it is a drawback, but it is we have to go with this. But this is a simple model and it doesn't take much CPU time and it is not very complex, right? So it is very popular, not in India, but almost all the countries of the world. Next, please. And go for the last. Yes, another important assumption here is the last bullet. If you see, pollutant is passive. We assume that pollutant does not react. Passive means it does not react. NO2 remains NO2 at the receptor because source is 3 kilometers away from the receptor. When NO2 is emitted from the source and then travels to 3 kilometers, NO2 does not remain NO2. NO2 will react with water molecules and then convert to HNO3. But this model assumes that whatever the NO2 is released from the source, it remains in the NO2 form. So that is why it becomes conservative, right? So that is what the assumptions of the Gaussian model, which makes it simple, good for the regulator, safe for regulators, but for the polluters, it makes them to spend more in order to control or manage the pollution. Next, please. This is the Gaussian equation. Again, it came from that generalized equation which I have shown you from the deterministic model. So that is the way the equation, workable equation, this is called workable equation, where has been derived. And in that book on the bottom, if you see, we have also included the derivation of this equation. The full derivation is there, that how we have received or how we have derived this equation from the general form, using those assumptions which has been shown to you in the last slide. So, and all the variables and parameters have been explained over here. And in this, the U is very important. Capital U, which you see over here, is a mean wind speed. I'm sorry, it's a small u, not capital U, which I have seen in the equation. This is the average wind velocity. And this average wind velocity is at the top of the source. If it is a stack, at top of the stack, where we measure the average wind velocity. And sigma y and sigma z are the dispersion parameters, dispersion coefficients, which is generally taken from the Pascal-Gifford curve, which I will show you in the next slide. Next slide, please. This is the coordinate system which we follow for this Gaussian model, x, y, and z. X is the direction of transport. As you see over here, there is a plume. Y is the perpendicular to the board or to the screen, which is a direction called Y. And Z is the vertical direction. X direction, diffusion is negligible. Y and Z direction, there is a diffusion takes place. So dilution is due to the dispersion, diffusion in the Y and Z direction. Again, in that book, which I have just shown you, all these things are mentioned in detail. Stability is an important parameter for the Gaussian-based model. And here I would explain only 3 types of stability: neutral, unstable, and stable. I think most of you people must be knowing, who has gone through the stability in the air quality in the basic fundamentals of the air quality. And neutral atmosphere is neither enhances nor inhibits the mechanical turbulence. Unstable is quite heavy turbulence, and stable is inhibits the mechanical turbulence. Right, mechanical turbulence, when I say, it is turbulence due to the presence of building, presence of trees, and presence of roughness. The wind turbulence is not there because wind is very calm in a stable atmosphere. So there is no turbulence due to the wind. And dilution is quite low. Unstable, dilution is very high. Neutral, dilution is okay, because here the mechanical turbulence and neither very high or not very low. Next, please. These are Pascal-Turner stability classes, which you can see from any book, or this is a very good literature which I have mentioned by Bruce Turner, which describes the full, in a very detailed, the dispersion parameters and how these stability has been classified, and how they have come with these alphanumeric words like A, B, C, D, E, F. These are the various letters which describe the very stability of the atmosphere. So this literature will mention in detail various alphanumeric letters, that how they are being derived and defined different types of stability. Next, please. Mixing height is another important input parameters for these models. And definition of mixing height, which I have mentioned over here, is the distance from the surface of the earth to the stable top of the stable layer. That is called a mixing height, and is also an important parameter. In summers, generally mixing height is quite unlimited, while in winter, like in Delhi, in winter mixing height go as low as 100 meter. Right? That is, up to 100 meter, there is no diffusion at all, no dispersion. Whatever the pollutants are emitted, within the 100 meters, if the source is like vehicle is within the 100 meters, the pollutants become stagnated. It does not disperse. That is why we say that exposure is very high, and there is episodes for that. While in summers, it is not like that. Summers, the mixing height becomes unlimited. Like the vertical line which you see over here, it becomes unlimited. It goes much beyond, in the Z direction. So it's an important parameter for the model. Next, please. These are stability curves for sigma Y and sigma Z. Again, in that particular workbook, which I have mentioned in the last slide, or in the book, in my book, which I have given in the reference, these Pascal stability curves have been explained more in detail, that how you are going to use these stability curves. It is between the distance downwind, that is the X direction, versus sigma Z, and versus sigma Y. So X, you know that because the distance where you want to find what is the concentration from the source, that you know the distance, and then you know the stability, whether it's a neutral or whether it's a stable. So you just draw a line from the distance up to that particular plot, and then you see what is the sigma Y and then what is the sigma Z. Next, please. Now, this is the Gaussian based models. Once you go for the stochastic based model, then as I told you, it is for the short-term predictions. All the statistical based model is for the short-term predictions, and it has three types of it takes a time series, because it's a database model, so it is a time series based models, all the stochastic based model. And when you say time series model, then there are three types of time series model. One is univariate, bivariate, and multivariate. So these univariate, bivariate, multivariate has been explained over here. But if you want to again go with the details, these references I have given, which you can see, and where detailed evaluation and detailed equations of these models have been given for one of the air quality control regions in Delhi, which is the ITO intersection, for which these models have been developed and then validated and checked with the observation data, and they worked very well. The predictions was very accurate when we compared with the observed data. So I don't have to explain here because of the time paucity, but I would suggest that those who are interested can go through these references which are available online. Next, please. Another good model is the hybrid model. That if you combine the deterministic model and the stochastic based model together, then you can cover the average variations as well as the episodes. That is the concentration in the, as I told you, concentration in the morning hours, which is very high, with concentration in the evening hours, which is very high, and then concentration between, say, 11 or 12 to 3, which is not very high. So if you want to cover all these three variations of the concentration of any pollutant, go for hybrid. You hybridize the deterministic as well as the stochastic model, right? So this has been, this hybrid model first was used by Jackman, as I told you in the reference over here, and he used this hybridization for pollutant concentration using the integrating deterministic model and the statistical distribution. So this was first done in 1988, long back. So we took this reference and then we developed a hybrid model for again ITO intersection in Delhi. Next, please. This is the hybrid model where we combined the general finite line source model and the LLD models, which is a statistical distribution model, and then we integrated that. If you see that equation, which is long equation, the first expression is the Gaussian model, that is GFLS, and the error function is the LLD model, which is one of the statistical distribution model. If you want to go into the detail, then you have to go for this reference of 2005, where we developed this hybrid model in these two references. So this model is quite accurate because it takes into account all the episodes, that all the exceedances, as well as the average concentration. Next, please. Another air quality model is the artificial neural network based model. Is again quite data intensive model, which we use the. It is a part of the artificial intelligence, which we used in back in 2004, where you have on the left hand side, if you see, you have all the data, meteorological data, as well as the source data. And then you go for a network which describes the traffic characteristics, which describes the source, describes the meteorology, and then you go for with the concentration of CO. And that type of model was developed back in 2004, again for the same hotspot, that is the ITO intersection, right? So this reference tells you how these type of ANN-based air quality models are developed and how they work. But they are quite accurate model, because only problem with this ANN-based model is that it needs plenty of data. Plenty of data it needs. The more the data you have, the better the prediction of these ANN-based models are. Next, please. Another category of the model is the neuro-fuzzy-based model. That is the you use fuzzy theory with the artificial neural network, integrating these two, right? So that is also based on the membership functions, that what type of membership function you use in order to translate the fuzzy rules into a quantified rules, right? Quantified functions. So, so this type of models uses the the data, as well as some rules which are made by the modeler, for that particular air quality control region. So it is a good model, but the only drawback of the neuro-fuzzy model is the membership functions. That what type of membership function you are going to use in order to define your fuzzy rules, because fuzzy rules has to be quantified, and that only can be quantified by using the MX. So that is a sort of a uncertainty which exists in the neo-fuzzy model architecture. But we worked this model again back in 2010, and the Suresh Jain was our PhD student now, who has worked on that. Now he is a professor in IIT Tirupati, and we again for the ITO intersection, again the same control region we worked. Why we did not change our location? Because we wanted to compare all these models, that which model is the best for which predicted the accurate prediction of the carbon monoxide. So that's what we did not change the location. We used the same location but used all the mathematical theories and developed the air quality model. Next, please. This is the table which tells you which one is fit for the urban air quality prediction. And if you see in that, the best model is the ANN-based model. It takes into account the non-linearity. It also predicts the episodic conditions. It also predicts the short-term predictions. It also takes into account by training data using map propagation, and it does not take into account expert knowledge. Expert knowledge is only taken in the neuro-fuzzy based model, but ANN-based modeling, our experience is that it predicted very accurate. However, the drawback is it needs a lot of data, plenty of data it needs. If data is less, then ANN will not work, the architecture will not work. But for the commercial models which you see, which you use, they are all deterministic based model, Gaussian based model, which are quite simple and quite conservative, though in prediction, but quite safe. Next, please. These are two commercial models which I have tell you many times earlier in the slide, AirMod and ADMS Urban. AirMod is a US EPA model. Our ministry also recognized this model, and which we use in India. It is a steady state model, and it is just improvement of AICTE 3, which long time back we used to use the AICTE 3. It's improvement in that. The AirMod used the input data of the upper meteorology. As I told you in the beginning in the slide, that it also used the input data in meteorology like ceiling heights. It also used the upper air data, say of beyond 1 kilometer, what is the wind velocity? Beyond 1 kilometer, what is the height of the clouds? These data you should have for that particular region from where you want to apply AirMod. So that is a bit problem, because these data we don't get in India. In US you get, but in India it is very difficult to get these data. So ADMS, they don't use the upper meteorological data, but it is not recognized by our ministry. It is a UK-based model, and it is developed by the Cambridge and Wagner Research Consultants Limited. It's a very simple model, Gaussian-based, but unfortunately, India don't recognize this model as a regulatory. And these two references which I have showed you, written you, it gives you the details of these two models which we have worked here by one of our research scholar, Dr. Sunil Gulia, who is also going to present you, in this course. Next, please. These are two more model, CalPUF model and CalRoads model. The CalPUF model is also US-based model, and it is a dynamic model, numerical model, not deterministic model. Again, when it is a numerical model, the CPU time is quite high. It takes a lot of CPU time, expensive model, non-steady state also, and good for the complex terrain. Say, for example, if it's a city like Visakhapatnam, where one side there's a sea, other side there is a mountains, there the deterministic model may not work properly. You have to go for the CalPUF type of model, numerical model. It's also long-range transport. There's 50 kilometers to 300 kilometers. It can predict, while deterministic model like AirMod, it cannot predict so much of distance. So every model has certain positive point, certain negative point. And it depends upon that how much accuracy and how much money you have got, and what is the facility you have got to use. CalRoads is a completely a model for the line source, that is the vehicular emissions, and it can also be used for the urban roads as well as for the highways. It is a US EPA regulatory model which US EPA use, but India, our ministry, it does not recognize that. So it is a research type of model which we use in many, institutions. This reference which I have mentioned you in the slide, where Sunil Gulia has, Dr. Gulia has compared the CalPUF as well as the AirMod for air quality assessment of industrial complex. So that has been compared, and see that how AirMod works and how CalPUF works. a quite interesting publication which you can see and of these two models. Next, please. EDMS is emission and dispersion model system. It is developed by again US administration, developed federal administration, and it is basically targets the prediction from the aircraft. That if you want to use at the airport, that what is the prediction of the what is the pollutant concentration when airplane takes off or airplane lands, how much concentration, how much emission, and what is the concentration of pollutants. And then air mod or a CalPerf or other model will not work. Go for the ADMs. So it is developed for such type of sources like aircraft, because when you aircraft take off, it needs a lot of engine power, so a lot of emission. And when it lands also, again, a lot of engine power and a lot of emissions take place. So in that case, a model like EDMS is quite good, and for that. CMAC is another model which community multi-scale air quality models. It is also a numerical model. It also takes into account the chemical. As you remember, in the Gaussian model, we told you that it assumes the pollutants are passive. While CMAC, they don't assume passive. They also take into account the chemical reactivity of the pollutants. So that is why it is a chemical transport model based on the Eulerian approach. And it takes into account that NO2 reacts or SO2 reacts. That reactivity is also taken into account. So it is more. However, as I told you, every model has certain positivity, certain negativity. This CMAC model takes a lot of CPU time, and it is not a regulatory model. I told you, it is not a regulatory model. It's a research-based model, scale model, and good for the secondary pollutants because it takes into account the reaction in the atmosphere and how these things take place. It is also based in US. It is developed in the United States. Next, please. So from this discussion, if you see that no single model can cover the entire set of impacts. So you have to select depending upon your resource, depending upon your facilities, that what type of model you want to use. If you want to go for the research purpose, you can select any type of model, depending on how much resource you have available. But if you want to go for the regulatory model, then only one model is available, that is the air model, which you have to use that. So, so the most suitable model, it depends upon you that what is model you want to decide. Right. So that is what in modeling there are constraints present. But for regulatory model there is no other model than the air model. Next, please. So that's all for you. That is the in brief. You can say that the air quality model predictions which are there for proper management of the air quality. It is essential to have a good prediction, a good forecasting of model, and for that a lot of parameters I have explained to you. What are the inputs I explained to you, and how you can use those inputs. So, so that is what the air quality depends. Thank you very much for your patience listening. And I know that it is difficult to explain everything in 1.5 hours. However, those references will help you a lot. Thank you. If you have any questions, please.
Hi, sir. This is Dr. Binaya from Nikama, Delhi. First of all, thank you very much for the enlightening session. It was a privilege to hear you, Professor. I have a very simple question for you. We all know, Professor, that industrialization is the backbone of economic development of any country. So how can we keep a balance between industrialization and lowered air quality pollution, please? Please enlighten us.
Yes, you are very, very important question in terms of the air quality management. I won't use the word urban because industrialization, when you talk about industrialization, it generally all the industries are there in the industrial areas, which are generally away from the city. Say, for example, Bhiwadi, I tell you the best example. Bhiwadi is near Rajasthan, and it is the most polluted area because it is full of industries, and it is not under the non-attainment cities, right? So in order to have a balance, and Bhiwadi is a town also, it is a spending town. A lot of construction is going on, lots of residential activities is going on. So in order to explain, in order to maintain the balance, as you asked, that how the balance to be maintained between the air quality and the industrialization, is that we have to have a proper industrial, management policy at the source itself. Because industries, if you have a proper control and management at the source, when I say source, I don't constrain to the stack source. There are a lot of fugitive source within the industry. A lot of fugitive means a lot of leakages are there. That also contributes to the pollution of the atmosphere. It's a cement industry. It's a cement industry. Cement industry has stacks. Cement industry has a plenty of pollution from the cement loading, cement unloading. These are the fugitive sources. So in order to maintain the balance between air quality and industries, it is easy to control at the stack. You can put ESP, you can put scrubber, you can put many control equipments are available. But if you don't have a proper management at the fugitive sources which exist in your complex, then your balance is disturbed, right? And you find these are the major lacuna in industrial air pollution control. That we don't go for the management. We are not very serious of the control of the fugitive sources, which becomes a major contributory source for the atmospheric pollution.
Okay, Professor, thank you so much. I have just quick 1 minute I'll take. I have a question. Actually, when the air pollution happens, does the pollution gets accumulated over the period of time? I know few things settle down because of the heavy rain, but still, I mean, how it works, I want to understand. But after the rain also, does it kind of come back to the water bodies or something like that? How the cycle happens quickly? Can you tell us, sir?
Yeah, it's a good question. The stagnation or the retention of the pollutant into the atmosphere depends upon the weather, and also depends upon the built-up area. If you see in the rural areas, the stagnation doesn't happen because their ventilation is quite high. When I say ventilation, the wind comes from some side, because wind has a direction, isn't it? The wind comes and goes. There is no obstruction, right? So whatever the pollution is generated in the rural area in terms of the running of the belgadi, running of the vehicles, running of the cycles, some dust is generated. It is not stagnated. It is, I should say, it is broomed from that particular site and diluted and discharged. However, if the built-up area is like city, like Delhi is ventilation coefficient is 0. I should tell you, there is no ventilation. Air comes and it doesn't have a place or space or location that it can take the pollutants away from the Delhi city. No, it doesn't have, because built-up area is very high. All the obstructions are there. So so what is the result of that? That whatever the pollution is generated or transported to be stagnated over the city atmosphere. So making or increasing the concentration of the pollutant. As you asked, when the rain comes, some of the pollutants are settled. Then you can see that AQI is reduced, because it is called washout. Pollutants comes to the land, right? And some of the pollutants like SO2, once rain comes, become H2SO4, says acetic acid. It may harm the soil. It may harm the grass. It may harm that particular land, right? So once the air is clean, but other ecological component is polluted.
Okay, doctor. Fine. Thank you so much, Professor. Thank you so much. Yeah.
Any other questions from the participants, please? Okay. Thank you, sir. I want to express my sincere appreciation for your exceptional speech and understanding fundamentals of air pollution. Your comprehensive approach to this critical issue has not only enhanced our understanding but also inspired actionable strategies for combating air pollution. Your ability to connect scientific principles with real-world application demonstrates your commitment to nurturing a sustainable future. Your insights encourage us to think critically and creatively about solutions that benefits both environment and public health. Thank you, sir. Thank you for your dedication and leadership in this environmental engineering field, particularly in air pollution and control.
Thank you. Bye-bye.
Thank you, sir. Bye-bye.
Thanks. Okay, participants, now Dr. Sudhir Daya will join within 2 minutes. Be online.
Sir, I already joined. Should I
Okay.
share my presentation?
Okay, sir. Just I am introducing you. Welcome, Dr. Daya. And Dr. Daya is now working as an additional general manager at EMG at NTPC Lara. Now he will be shifting to the focus on environmental challenges posed by coal-based thermal power plants all over India. And Dr. Daya has more than 25 years of experience in the energy sector and will be discussing the crucial role coal plays in Indian energy matrix and associated environmental problems, including air pollution, water pollution, and waste management. He will also be highlighting the measures being adopted by NTPC to reduce the environmental impacts of coal-based power plants for long-term sustainability. Thank you, sir. You are welcome, sir. Now you can start your presentation, please. Hello, sir. Sir, please unmute yourself. Yes, sir. You are
The
not
presentation is visible?
not yet, sir.
Okay. I will share again.
Okay, sir. You are visible, sir, but the presentation is not visible.
But now it's visible, sir?
Not yet, sir. Go to the full screen mode, please, sir, in the PPT.
Just 1 second.
Anil.
Is it visible now, sir?
No, sir.
Share your entire screen.
Please share your entire screen.
Please share your stop sharing, then share again.
Dr. Rao?
Now it's visible, sir.
Sir, please stop sharing right now, and then you can share the entire screen.
So I did that only.
Okay.
Or you can share, Dr. Raut, your screen with sir's presentation and he can present.
Ma'am, I made some changes, ma'am.
Okay, okay. Then we'll wait for.
Yeah.
Chadrik sir, good evening.
Good evening, sir.
सर कितनी देर में शुरू होगा दोबारा?
अभी just
Sir, presentation में कोई issue आ रहा था, बस we are starting. Give us few minutes. हाँ जी. और आप कैसे हैं sir? All well? Yeah, good evening.
हाँ जी मैम, अच्छा चल रहा है.
जी.
Raut, please share that presentation only. It's not allowing me to share. Am I audible?
Yes, sir. Yes, sir.
Yeah, please share. It is not allowing me. It's showing some error while sharing the screen.
Okay, sir. अब क्या करना है?
Now, sir, probably you can take the presentation from him and you start presenting it, and from the other side, the presenter would talk, if that is okay with you.
Raut, it's showing. Sorry, you can't share the slide. An error has occurred when screen sharing.
Okay, sir.
Please
I
try
am
again.
setting the PPT. I am actually sitting some other system. I am just quickly solving this. Okay, sir, now it is visible?
Yeah, it's visible. Please.
Okay, sir. Sorry for the disturbance, interruption. You can start now, sir, please. Yes, sir.
Good evening, everybody. Thanks to organizer for providing me the opportunity to share my experience in field of coal-based thermal power plant and what our company is doing. I am working in NTPC and presently I am posted at Lara station. It's near Raigad, Chhattisgarh. Next slide, please. Either give me control, then I will move from my side. This will be outline of my presentation. Next, please. Basically, right now some discussion was going on that how we can make a balance between industrialization and how to manage the air pollution and not only air pollution, basically all type of pollution from industrial development. And energy or electricity is a primary requirement for development of any society or country. That's why that electricity capable of improving the living standards of billions of people. And in developing countries who lack access to the services or whose consumption level are far below in comparison to the people living in industrialized countries, there is a huge gap in the electricity consumption. Next slide, please. Next, please. Yeah, here we will see the comparison. This is basically a pictorial presentation of per capita electricity consumption and the per capita GDP. Please scroll a little bit more. Basically, if you will see that where India is there, and per capita electricity consumption per annum, if it's going higher, and you will see in this circle, then there is no country wherein there is a low per capita energy, and that country is having higher per capita GDP. It means electricity consumption or energy consumption is directly relevant with the development of any nation or society. Next, please. Now we will discuss how in our country, what is the condition. This is per capita electricity consumption. In March 2002, it's basically on financial year basis. In 2002, it was 559 unit electricity per year. And in March 22, it was 1255. But what is the international or what is the global level? Next, please. This is the worldwide consumption of 2022. And India's consumption was 1297 unit electricity per year per capita. And where the Iceland, Norway, Kuwait, Qatar, Canada will start from upper side. And even China is per capita consumption is 6199. And even world average is much higher than what we are consuming right now. It means if we want to be developed countries as per our government target, that by 2047 our country will be a developed country, then definitely there will be increase in the electricity consumption, per capita electricity consumption. And as our population is also higher, it means our total electricity consumption will be much higher. Next slide, please. These are some predictions. Next, please. A little bit more. Yeah. These are predictions up to 2047. This projected consumption is that our per capita consumption will touch 3000 kilowatt hour per year. If that will be the scenario, what will be the energy requirement in billion units in the country, which is right now 243 billion units here in 2024. and the installed capacity, and that will touch to 575 gigawatt total load, and billion unit will touch somewhere 3776. These are the projected numbers. If that is the scenario, it means we have to increase the total installed capacity, total generation of the power. And if there is power generation, in next few slides I will discuss that major contribution in power generation in our country is still from coal-based power plant. This is the installed capacity as on 31st December 2024. And we will see the installed capacity of 2,44,377 megawatt, which contributes 52.9%. It's from fossil-based power plants. And alone coal-based, 46% is being contributed. This is the installed capacity, basically. And then lignite-based, 1.4%, gas-based, 5.4%, diesel is very small. Then we are coming to non-fossil-based electricity. This is the installed capacity, which contributes 45.3%. And nuclear contributes 1.8%. And total installed capacity as on 31st December 2024 was 4,62,000 megawatt. Next, please. Please continue. These are the pictorial presentation that which type of plant is in which area. Next, please. Yeah. This is the, again, installed capacity in presentation in different way. Next, please. I will go to generation only. Yeah. This is the very important, the total generation and growth from 2009 to 10 to 2024-25. How the total generation is increasing, and what is the growth of the electricity generation in our country. In 2009-10, total generation was 808 billion units approximately, and annual growth was 7.5%. If you will observe that whenever you will match this with the GDP of the nation, then definitely you will correlate the things. In case of COVID, if you will see the values in 2019-20 and 2021, the percentage growth of the power generation was 0.95 in 1920, and in 2021 it was negative basically. And after that again 21-22 approximately 8%, 22-23 8.89%, 23-24 7.06%. What was the projected scenario of the electricity consumption and projected for 2040? That will indicate that how much additional installed capacity will be required and what type of installed capacity we will get, either coal-based or entire renewable. Next, please. This is again like one pictorial view of the how that electricity generation increase. This is shown as 0.5% negative in 21-22. This is the power supply position in the country during 2019-10 to 24-25. This is the peak demand basically. And in peak demand, what is the condition? Whether we are having the capabilities, we are having the installed capacity, and we are fulfilling the peak demand, or there is any deficiency in that. That requirement was in 2009-10, I will take example, 8,30,000 million unit, and availability was less than 8 lakh million unit. And there was a deficit. Likewise, the deficit is going on decreasing. And in 2024-25, we can say that our requirement was this is data is up to December 24 basically, 12,80,000, and the availability generated capacity generation is 12,78,000, and hardly there is a very small gap, which was somewhere 10% in 9-10, which is reduced to 0.1%. Next, please. This is the total generation from renewables. If you will see that our contribution from all sources including renewables. In 910, 805, and in 2023-24, it is 1734 billion units annually. Next, please. This will show that what is the scenario, why coal-based power plants are in emphasis, and why there was a pause on the construction of new power plant during last 8-10 years. And now from last 2 years, again, there is a restart, we can say, for coal-based power plant. And now government is asking to install additional 80 gigawatt. We can say 80,000 megawatt of coal-based power plant in India. This is the PLF, just please. This is the PLF of the coal-based power plant. In 910, PLF of coal-based power plant was 77%, and which goes decreasing, and again it is it is increasing. It means the demand, basically PLF is plant load factor, that how much time plant is on bar or plant is operating, and it's increasing means power plant, coal-based power plant are operating maximum time. It means we can say at and this is the sector-wise, central government, state government, and private. And this 74.19 is from central. Central means companies like NTPC or NLC or NHPC. Next, please. This is the power generation. This is the installed capacity, and this is the generation, and this is the percentage contribution. If you will see the installed capacity power mix as on 31st December 2024 in the left hand side, total installed capacity is 462 gigawatt, and the percentage 47.4% is from coal based, then biomass based, wind power, solar is 21.18, small hydro is 1.1%, oil and gas, nuclear 1.77%, and hydro is approximately 10%. But how they are generating the electricity? At right side, it's showing that total energy generated, just 1 second, 72% electricity generated, that is from coal-based power plant. It means still more than 70% electricity is being generated from the coal-based power plant, even though installed capacity is 47%. It means environment management in coal-based power plant is very crucial if you want to generate electricity in an environment-friendly manner, and you want to reduce the pollution due to electricity generation. Definitely that renewable source, and there is a more emphasis of government on the solar also, due to that storage system and other constraint, and only during daytime generation is possible. If there are viable and low cost energy storage system will come, that work is going on, and we are expecting the breakthrough very soon, then that scenario will change. Next, please. This is the installed capacity of NTPC as on 31st June 2024, from which the company I am belonging. Our total installed capacity was 76,000 megawatt, out of which more than 53,000, approximately 54,000 is coal-based power plant, that is 70%. Then gas and waste 4,000, hydro 800, renewable 501. This is from the NTPC and its subsidiary and joint venture companies. Coal is again 8,000 megawatt, gas based approximately 2,500 megawatt, hydro approximately 3,000. This is the, we can say, the energy mix of our company. Next, please. Just please. This is the capacity addition planned by NTPC. Right now, installed capacity as on that date mentioned 76,000, and under construction 21,000, and target of the company by 2032, that is 130,000 megawatt plus. And this is energy mix shown, that coal based, hydro, RE 21,029, which is under construction. Next, please. And one more thing, important thing to highlight. Earlier slide, please. Out of this coal-based 9,560 megawatt, 8,240 megawatt is supercritical based. Basically, supercritical based units are consuming less coal. Those units are more efficient in comparison to the subcritical units. Ultra supercritical and supercritical. Now there is no subcritical unit under construction in the NTPC fleet. Next, please. Now I am coming to environment. Basically, what is environment? I will little bit touch because all are aware of this. This is the wholesome context of the human life, or we can say wherever we are living, our interaction of any living being with the its surrounding, either that is living or non-living. Next, please. It consists of both biotic and abiotic. Next, please. These are the segment: atmosphere, hydrosphere and lithosphere, and biosphere. All these influence one another. Main concern is what is the pollutant. Well, because if I am discussing about coal-based power plant, this is the industry which is highlighted by everybody, that coal-based industries are doing maximum pollution. What is a pollutant basically? A substance which is present, and if its concentration crosses a threshold and it starts causing the detrimental impact on the environment, is known as pollutant. Anything, even if it is essential for life, if the concentration of that essential part, if that is crossing a threshold, it became detrimental to the system. Next, please. Then what is contaminant basically? A material which is not naturally present in the nature, but it is introduced by the human being. And if the concentration of these contaminants crosses again a threshold and it became detrimental to environment, we will again call it as a pollutants. These are the main effects of environmental pollution. Everybody is aware about the health effects. If there is air pollution, then there will be respiratory issues. There is a water pollution. For example, if there is a fluoride in the drinking water, there will be fluorosis, dental fluorosis, skeletal fluorosis. Just please don't move earlier. Yeah, please. Then next one is economical problems. This is the issue which is least highlighted by environmentalists, NGOs, or whatever the regulatory bodies, because these are the silent progress in this field. If you take example, if there are fishermen and some pollutant is being discharged, there is so much of hue and cry about the water quality of Yamuna. There was a time when people used to swim or used to consume the water from Yamuna, and these days what is the condition? In the similar manner, there are many water bodies from which fishermen were earlier catching fish and they were learning their living being. Due to pollution, either air and wet deposition and dry deposition from the atmosphere or discharges of liquid effluents affected the health of the water bodies, and the fishes available in those water bodies, due to different issues like eutrophication and other issues, those fishes get eliminated, and the living being of those fishermen, now those fishermen are doing some other job in place of doing fishing. These type of economical problems never took that much space in the discussion of regulators or industrialists or policymakers. But definitely there are issues. Next is ecological problem, and aesthetic issues is one of the concern. Everybody must be aware about the change in the color of Taj Mahal due to some industries in the trapezium of the Mathura area and Agra area and Firozabad, that Bengal business and other things. And now things changed after one decision by higher judiciary and shifting of some industries and some other action taken by the regulators. Next, please. Now I will come to the business type of pollution from coal-based power plant. Basically, these are the major type of pollution which is being assessed, monitored, regulated by regulators. Air pollution. Basically, main raw material of coal-based power plant is coal. that if there is an environment management system is not in place, and if that is in place and that is not operational, then air pollution start from the coal loading in the transport mechanism of your plant. If you are bringing the coal by your dedicated MGR or by railway tracks or by road, majority of cases, coal transportation by road to any coal-based power plant is not allowed. In few exception, that is permitted, and that is permitted temporarily. In case of NTPC, NTPC is not transporting any coal by road. NTPC is having either dedicated MGRs for their station. Likewise, in our station, we are having dedicated MGR of 65 kilometers from mine end, and we are having the electric loco. Our full MGR is fully electrified. That first MGR in India, which is fully electrified, and we are having electric loco, our own infrastructure, and we are bringing coal from NTPC own coal mine Talaipalli, 65 kilometers away from our plant, and we are bringing coal to our plant. At the time of unloading, again, if you will unload the coal from the racks, either by wagon tippler or by track hopper, there will be fugitive dust. If there is no dust separation system and that is not being maintained and operated as per their design, and being a central PSU and the leading or major power major in the country, these systems are in place, and I invite any member at any time, please visit our plant. And this is we can say, one of the most efficient plant in the NTPC fleet, which is super critical and having 2 units of 800 megawatt operational. Then after unloading of coal, we are taking this coal to crusher house where we are crushing the coal, which is also air pollution source. If dust extraction and dust separation system, DDS system, which are in place and not operational, then that can be a serious concern. As I already mentioned, that we are having system in place and we are operating those systems. And then we are storing the coal in the yard. It means these are the points where there are the possibility of air pollution. As Dr. Mukesh Khare rightly mentioned, that emission from stack is being monitored, online monitored by regulator. Data is online going to state and central regulator. But the issue is with fugitive. He was very rightly mentioned that issue is with the fugitive source, material handling. As he mentioned the example of cement industry. In likewise, if you are handling coal in large quantity, if I will take example of my station, our station is 1600 megawatt, and hourly consumption of our station is approximately 1000 ton per hour. And in one day, our station is consuming approximately 24,000 coal per day. Coal is coming through racks. If it will come through by road, then 30 ton coal in a truck, then we can calculate how many truck of coal will come if we transport the coal by road. That will be additional pollution of air pollution. Then we are taking this coal for burning in the boiler, and after burning, that major concern is fly ash. There are 2 types of ash is generated. One is bottom ash, which is being collected in the bottom ash hopper in wet form. That is not a concern. Second one is the fly ash, which is going with the flue gas. And NTPC has installed more than 99.97% efficiency ESP in all its stations. Even in case of old power plant, NTPC has renovated all the ESPs, and now efficiencies of all, even the older unit which were installed even prior to 2000, that efficiency of all ESP is more than 99.9%. And the design emission from our plant where I'm working, that design emission is just 18 milligram per normal meter cube. Limit applicable as on date for our plant is 30 milligram. And NTPC designed the system that is 18 milligram per normal meter cube, and which is being operated on its design efficiency. Related to other parameter, I will discuss when I will discuss the new norms. Next is water pollution. Basically, there are 3 inputs. One is air, water and coal. In case of water, we are taking water from Mahanadi, which is 38 kilometers from our plant. And it is being used for our boiler system and cooling system, in addition to service, firefighting, and other usages like ash disposal. Effluent treatment plant, coal slurry settling ponds, and sewage treatment plant are in place and in operation. And I can say that our plant is working in ZLD, zero liquid discharge condition. It means there is no effluent, either treated or untreated, is being discharged outside our plant premises. Either this is our main plant or township or S storage area, which is known as S dike area. No water is being discharged from any premises of the NTPC Lara, or I can say from any station of NTPC, as NTPC has proactively taken assignment of converting its all plants. Either it is commissioned recently or these are old plants. Modification are made, and now all plants of NTPC are in ZLD condition. Land pollution is not a concern in case of coal-based power plant, except if there is any fugitive scenario, incidental from ash dike, or as I mentioned, then only that deposition, either that is wet or dry deposition, that can contribute, but no such observation are observed, at least in station of and where right now I'm working. Next is noise pollution. Basically, systems are in place, but only at the time of plant shutdown or forced shutdown. If there is a steam discharges, there are some momentary elevation in the noise level, but levels at the boundary of the plant are well within the limit, which are being monitored and being reported to the state and central regulator. Thermal pollution, because these next two are mentioned in blue color. Thermal pollution is applicable only for the open cycle units. Open cycle means when that we are using water once and we are discharging water to the water body from which we are drawing water, or any other water body. These days, open cycle operation of coal-based power plant is not permitted, and it is mandatorily that there will be cooling tower, and no discharge is allowed these days from the coal-based power plant. Radioactive pollution, basically there is radioactivity is being not being handled in any of the coal-based power plant, except some sources for the radiography test of the boiler tubes, and that source is being maintained in an intact form. Those are known as gamma cameras for the RT test, radiography test, to check the quality of weldings. Otherwise, there are some conditions by the regulator that there is a radioactivity in coal, and which is being monitored on annual basis, and there are some guideline from Atomic Energy Regulatory Board, and it was categorically mentioned if in coal-based power plant are using Indian coal, there is no requirement of radioactivity monitoring, as radioactivity level in Indian coal and ultimately in the fly ash is much lower, and which need not any monitoring or regulation regarding the radioactivity. Next, please. Next, please. Please move the slide. Action. Rahul, next, please. Sir. Next slide, please.
Sir, wait, please.
Yeah. Thank you. This is a graphical presentation, operation of the power plant. And next slide, please. Yeah, this is the material flow. I will take little bit time on this slide. Basically, these are inputs: fuel, coal, gas, LDO, HFO. In case of coal-based power plant, coal, LDO, or HFO. These are the liquid fuel to start for the startup of the plant. Then air, auxiliary power, which is being used from the electricity generated. Then water or recycled water. And the outcomes are, in case ultimate aim of electricity generation, then air emission, particulate matter, CO2, SO2, NOx, and mercury. Prior to 2015, only particulate matter was being regulated by the regulator in India. And even as on date also, CO2 is not being regulated. There are guidelines as per 2015 notification for particulate emission, sulfur dioxide, NOx, and mercury. And next is, as I mentioned, that the S, that is fly ash and bottom ash, there is a regulation. I will discuss that we have to utilize the fly ash 100%. And next environmental concern is waste is being generated because we are using heavy machinery, then used oil, lube oil, used grease. Then in case of maintenance work, oil gets spilled sometime. Then we have to remove that oil by using either oil soaked cotton or by sponge or by other media. That we cannot mix oil with water because treatment will become more difficult if there is a mixing of oil, even though there are systems. And for traces, there are systems installed in our plant as well. Next one is meal rejects, because when we are NTPC all pulverized coal-based plants, for that we have to bring the coal to a specific particle size. For that purpose, we are grinding the coal in the coal mills, and the hard portion that is coming at the meal reject, which is having some calorific value as well. We have to manage that waste. As we are using the energy storage system, either in the even our auto base, also in vehicles we are using battery, and even for the UPS, for the power backup we are using batteries. And after its usable life, used battery are also a waste. We have to handle that as well. Then we are having our hospitals in plant also and in township also. Then biomedical waste is being generated, and there is a township, and even in the office premises also domestic waste is being generated. And we are a power company, and we are using computer system, communication system. Then e-waste is also being generated during this entire power generation process. And there is a system in place. In case of emissions, I will discuss in detail. Earlier, I has mentioned that we have installed the ESP system of very high efficiency, as mentioned, 99.97% efficiency at our plant. And in case of coal ash, we are having ash dike and dry ash systems. In case of waste, we are having policy in place. There is a guideline. Name of guideline is zero deviation document. It means no deviation is allowed while handling the waste and managing the waste. Whatever the SOP are finalized by the top management, that is being implemented at all stations without any deviation. Next is effluent. When we are using water, either in plant area, different type of effluent is being generated. One is main plant effluent. Next is we are handling coal. At the time of unloading of coal or crushing of coal or storage of coal, we are spraying water for the fugitive dust control. When we are spraying water, that water is getting accumulated, and through the effluent drain that is coming to coal slurry settling pits, where we are treating that waste. We are removing the coal particles. We are using that coal particle in our boiler, and we are using the treated effluent again for the same purpose, for dust separation in coal handling area. And next is domestic effluent. As we are having townships, and for the manpower in plant area, we are having the utilities, entire affluent, that is domestic affluent from plant area and from township, that is being collected, and we are having the sewage treatment plant of 1.7 million liter per day capacity in our township, which is MBBR based and compliant to latest norms notified by MOEF and further mentioned by the NGT in its order. Station STP is in compliance to those norms. Next, please. This is just please. This is the for the regulation of any industry or for protection of environment. There is a provision in our constitution itself. We are talking about the legal framework. It is mentioned in our constitution in Article 21, and that fundamental right. I will discuss in my next slide how that is elaborated by our Honorable Supreme Court, and now that became the fundamental right, that access to pure air and pure environment, water, is the fundamental right of every citizen of India. And in Article 48A, Directive Principle of State Policy, that is mentioned in Article 51AG, fundamental duty, it is also mentioned that we have to protect the environment and wholesomeness of the environment, and we have to take care of wildlife and forest. Next slide, please. Yeah, please. The fundamental right to life is guaranteed to all persons. No person shall be deprived of his life or personal liberty except according to the procedure established by law. This is Article 21. The scope of right to life expanded by higher judiciary, that is Honorable Supreme Court. Now it includes that right to clean and pollution-free environment. That the definition of right to life was further expanded by Honorable Supreme Court. That right to life is right to clean and pollution-free environment. Next, please. In the directive principle of the state policy, states shall endeavor to protect and improve the environment and to safeguard the forest and wildlife of the country. It is mentioned in our constitution, and the environment is a concurrent subject which is being looked after by center and state both. And in this definition, state is, it means the government, either that is center or state. In case of fundamental duties of citizen to protect and improve the natural environment, including forests, lakes, river, and wildlife, and to have compassion for living creatures, which is mentioned, it's our duty of every citizen of India that we have to contribute. If we are having rights, we are having duties as well. That is also mentioned in our constitution, that we have to take care of forest, lake, river, and wildlife. Next, please. This is the legal framework for coal-based power plant. These are the act and rules which are directly applicable on the coal-based power plant. First one is the Water Prevention and Control of Pollution Act 1974 and amended in 2024 as well. Next is Air Prevention and Control of Pollution Act 1981. And next, Environment Protection Act 1986 and related rules notified by the gamut of this act. Basically, first two act, Air and Water Act, to run any industry, and especially in case of coal-based power plant, which belongs to a red category, we need permission from the state board and center board, or MOEF we can say. If we want to establish a power plant, we have to take the permission from state and center both. MOEF is issuing the environmental clearance after the proper procedure of environmental impact assessment studies, some public consultation, then we are approaching the MOEF for the environmental clearance. After getting the environmental clearance, we have to approach the state boards. Then they are issuing the consent to establish. Without the consent of the State Pollution Control Board, no one can construct any power plant in their state. That consent to establishment is being issued under the both Air and Water Act, and environmental clearance is being issued by the MOEF under the provision of Environment Protection Act 1986. Then next is Environmental Appellate Authority. Next is, because we are using some hazardous chemical or material, or we are storing the large quantity of coal. For example, at our station, we are storing more than 4 lakh ton of coal. At any point of time in our yard, we are having that much quantity of coal. To avoid any issue of generation if there is a deficiency of coal. Then if there is a huge quantity of coal or LDO, we are storing at our site. We are storing hydrogen, and earlier we were storing chlorine as well. These days we have phased out the chlorine based systems, and we are using now chlorine dioxide system for our all water treatment purposes. Then we have to take the public liability insurance under the provision of Public Liability Insurance Act. If there is any mishappening, unfortunate happening, and there is a damage to the public in our vicinity, that will be covered from that policy which we are purchasing for all plants of NTPC Limited under the provision of Public Liability Insurance Act 1991. Then majority of you must be aware about the National Green Tribunal, NGT, which was established in 2010. And as I mentioned, that we are using some source also for our testing purposes. Atomic Energy Act 1962 is also applicable. Wildlife Protection Act 1972. In case of coal-based power plant, if any sensitive area, restricted area, protected zone, any wildlife sanctuary or national park, or any preserved or protected area is in the vicinity of our plant, then this will be applicable, and then we have to comply all the conditions stipulated by the department related to wildlife management plan of the respective station. But for example, at the station where I am working, there is no such area in our vicinity. Next is Motor Vehicle Act. As we are transporting many equipment and many materials through road also. For example, we are sending the flyers for the road embankment and low-lying area development. That Motor Vehicle Act come in the picture, that we have to comply all the condition of Motor Vehicle Act also, that there should not be any overloading and violation of the whatever the provisions are there in the Motor Vehicle Act. Next is Forest Conservation Act 1981, and an amendment is 2020. That is also applicable on the coal-based power plant or any industry. If we will use the forest land while the construction of land, we have to take the forest clearance for the land, and we have to do the that forest compensation. We have to do the additional plantation. We have to send forest clearance compliance after half yearly basis to the concerned department in the state, that is this DFO office of the respective districts. Next, please. These are some sections of Water Prevention and Control of Pollution Act 1971, because this is the Air and Water Act. These are the primary act under which we are getting the permission to establish and operate the power plant. In the section 16, subsection 3, there is a provision to establish or recognize a laboratory by Central Pollution Control Board. In section 17, subsection 2, powers are there to establish or recognize a laboratory by the State Pollution Control Board. And under section 18, that Central Pollution Control Board is that can give the direction to the State Board, Pollution Control Board. There is no, both are autonomous body. One is reporting to the state, one is to the central government. But in few cases, as this is a concurrent subject, Central Pollution Control Board can give direction to the State Pollution Control Board under the section 18 of this act. Section 19 gives the power to state government to restrict the application of this act. It means if state government or central government, even if they wish that they want to exempt some certain area, for example, if there is some area of army cantonment, we can say, or any strategic work related area, that state can exempt that this is a restricted area and this act will not be applicable in that area. That power is there in Section 19 of the Water Prevention and Control of Act 1974. Section 21, power to take sample of effluent and procedures. Under this section, state regulator can enter any industry, not only power plant, any industry which needs the consent or that this act is applicable on those industries. They can enter at any time to that industry premises and take sample of effluent. Then Section 22, report of the result of analysis on the sample taken under Section 21. Section 24, provision on use of stream or well for disposal of polluting water. It means under Section 24, they can restrict any discharge these days. No discharge is allowed to any industry if that belongs to red category, and power plant which are established after 1st January 2017. There is a condition in the MOF notification itself that ZLD condition is applicable to the all plants which are commissioned after 1st January 2017. Section 25, restriction on the new outlet and new discharges. If you want to establish a new power plant or a new facility in your industry or your power plant, then you have to take permission from the state regulators, that is State Pollution Control Board, that you want to establish one additional facility and that much quality of effluent will be there. This will be the quality of level, this will be the quantity of effluent, and we will install this type of the treatment system, and our treated effluent will be of this quality. Then regulator will decide, state board will decide whether they will allow you to discharge any effluent to any stream or not. Next is Section 27, refusal or withdrawal of consent. That consent is being issued under the provision of Section 24 and 25, which state board can withdraw or refuse to give consent under Section 28. Even though industries are having the provision of appeal against that Section 28, that refusal or withdrawal, but hardly any industry is taking that route, because normally if there is any compliance, state board are also considered, because everybody wants the development. If you will comply the condition, hardly condition arises that board is creating such condition that there is a refusal or withdrawal of any consent. In Section 32, emergency measure in case of pollution of stream or well. If there is any emergency or there is any incident and some water is get released from any industry or any facility, then you have to inform the state regulator that due to this incident, that much quantity of effluent, treated or untreated effluent, is released from our facility, and this type of action we have taken. Then we have to send that information to the state regulator. And under Section 33, State Pollution Control Board is having power to approach the board against any industry if there is any violation and mitigation steps are not being taken properly or as stipulated by the regulator, those are being not followed by the industries. In such scenario, under Section 33, State Pollution Control Board can go to court as well. And under Section 33A, regulator can give direct direction to the industries that you are doing that much of deviation. Stop this, otherwise we will send the closure notice or we will withdraw the consent of your industry. Next, please. This is the gamut, or we can say umbrella act for any industry in India, and it was notified in 1986. There was a major reason, all of you must be aware about one incident in Bhopal, and at that time there was no such major act available to regulate such type of scenario which was happened in that year. And after that, this comprehensive act notified by the central government, and there are n number of notification guidelines are being issued, including the new norms notified on the 7th December 2015 for the coal-based power plant. I will discuss in detail in next few slides. Next, please. This act gives the power to Ministry of Environment, Forest and Climate Change to lay down the standard for the environment quality, emission or discharges of environment pollutants from various sources. Devise procedure for handling the hazardous substance. Formulate rules for the locating the industry. Which type of industry you can go for establishment in which type of area, what will be the condition applicable, that MOF formulate that type of criteria. Mandate compulsory reporting of environmental pollution by the industries. Provide for provision for the recovery of cost of cleanup from the polluter. That polluter pays principle started in India after this act only. At the time of Bhopal incident, there was no provision from whom that cost should be recovered to treat the waste that was left over after the incident. These days, there is no concern after the notification. These are the different notification and rules notified by the MOEF under the provision of Environment Protection Act 1986. For example, directly applicable to coal-based power plant, Fly Ash notification 99, 2003, 2009, and amendment thereof, and recently notified one notification on ash utilization in 2024 as well. Battery management and handling rule 2001 and again revised in 2022. EIA notification 2006 and amendment thereof. Then National Ambient Air Quality Standard 2019, on the basis of which all of you must be aware about the air quality index is being notified. That is based on those parameters mentioned in that notification, NOx Standard 2009. Regulation and polychlorinated biphenyl order, new emission norms for coal-based power plant, new standards for sewage treatment plant, then solid waste management rule 2016, biomedical waste management rule 2016 and amendment, hazardous waste and other waste management and transboundary rule 2016, e-waste management rule 2016 and amendments, then solid waste management rule 2016, construction and demolition waste management 2016 and amended in 2024, plastic waste management 2016 and amendment in 2023. These are the all rules and notification notified by the MOEF and CC, which are applicable on all industries if they are generating that type of waste. For example, fly ash is being generated either by the coal-based power plant or the industry which are using coal as their fuel. Next, please. Under provision of Environment Protection Act, new norms for coal-based thermal power plant. Those are notified on the 7th December 2015. Next, please. These are the, these are the scenario. Earlier, as I earlier mentioned, there was regulation for particulate matter only. This S is not there basically, that is particulate matter. And the applicable norms was earlier 150, which was reduced to 100 and final 50 milligram per normal meter cube. Prior to 2015, there was no norms for the sulfur dioxide emission from the coal-based power plant. Only there was a dispersion by the, which was being regulated by the stack height depending on the capacity of the coal-based power plant. For the NOx, there was no norms. Mercury, there was no norms. On the 7th December 2015, this notification came and there was limits stipulated for the units depending on their date of commissioning and their size. All the units commissioned from prior to 31st December 2003 having the capacity less than 500 megawatt, because on the megawatt or size of the unit, inventory depends that how much pollution will be generated from that unit. Based on that limit for sulfur dioxide, stipulated limit was 600 milligram per normal meter cube, or for the unit 500 megawatt and above, and unit were commissioned prior to 31st December 2003, limits are 200 milligram per normal meter cube. For NOx, earlier there was no norms, and for the unit commissioned prior to 2003 December 31st, irrespective of the unit size, stipulated limits are 600 milligram per normal meter cube. For particulate matter, limits is 100 milligram per normal meter cube. And for the mercury, for the unit less than 500 megawatt and commissioned prior to 31st December 2003, there is no limit for the mercury emission. Just please hold, please don't scroll, please. For the unit commissioned before 31st December 2023, mercury is 30 microgram, or we can say 0.03 milligram per normal meter cube. Little bit above, please scroll back. For the unit commissioned after 1st January 2004 and up to 31st December 2016, unit less than 500 megawatt, again SO2 limit is 600, and for unit more than 500 megawatt, again unit is, that limit is 200 milligram per normal meter cube. In case of NOx, that 300 milligram was notified on the 7th December 2015, but after persuasion by the operators with Ministry of Power and Ministry of Environment and Forest and Climate Change, this unit is revised to 450 milligram per normal meter cube. In case of particulate matter, emission limit is 50 milligram. And for mercury, irrespective of the unit size, the unit commissioned after 1st January 2004 and up to 31st December 2016, limit is 0.03 milligram per normal meter cube. And in the last column, for the unit which are installed after 1st January 2017, for the SOx, limit is 100. For NOx, limit is 100 milligram. For particulate matter, limit is 30 milligram per normal meter cube. And for mercury, again, irrespective of unit size, limit is 30 microgram, or we can say 0.03 milligram per normal meter cube. Prior to 2015, there was no limit on the water consumption, specific water consumption. It means that how much water we are consuming to generate 1 unit of electricity. After 2015, applicable limits for the unit commissioned prior to 31st December 2016, limit is 3.5 cubic meter per megawatt hour, or we can say 3 liter per kilowatt hour. It means whatever we are using common unit of 1 unit electricity, which is equivalent to 1 kilowatt hour, 3.5 liter water is permitted for consumption to generate 1 unit of electricity. For the plant commissioned after the 1st January 2017, earlier notified limit was 2.5 liter per kilowatt hour. After persuasion, as there is a regulation of sulfur dioxide, for which plant needs the flue gas desulfurization FGD plant, which also consumes some water. Then this limit was revised from 2.5 liter per kilowatt hour, or 3 cubic meter per megawatt hour, from 2.5, which was notified in the original notification. Next, please. This is the chronology of the new emission norms. Just please hold. It was notified on the 7th December 2015. This is typographical error. This is not 2021. This is 2015. MOF notified the new emission norms. Then, considering the fact and ground reality due to the constraint in the erection agencies and their resources, then corona issue, then the timeline was extended up to 2024. In that notification of the 28th June 2018, then chimney height was revised. I will discuss that also in next few slides. Earlier, what was the stack height, and now what is the stack height applicable to the coal-based power plant. And the specific water consumption limit was revised, as I mentioned, for the unit commission after 1st January 2017. Earlier limit notified was 2.5 liter per unit generation, which is revised to 3 liter. And on the 19th October 2020, NOx limit earlier, which was notified as 30 milligram, that was revised to 450 milligram per normal meter cube for the unit commission from 1st January 2004 to 31st December 2016. Then Honorable Supreme Court gave some direction for the units in the NCR region because due to delay in the commissioning of FGD and other systems for the compliance of these norms. Then MOEF notification 31st March 2021 extended the timeline, and units were categorized by the Central Pollution Control Board in 3 categories: category A, category B, and category C. And they also came with the provision of compensation. A power plant will not commission FDD. They will not control the SOx, NOx, or mercury or particulate matter as per the limits stipulated in the new norms. There will be environmental compensation on the power plant. On the 5th September 2022, this timeline was again revised due to delay in the commissioning of flue gas desulfurization system. And again, last month only, this timeline is further extended for 3 years. I will discuss in next slides. Next, please. Earlier, there was a timeline. I will take example of the Simadri. There was an NTPC station mentioned at serial number 7 mentioned in Andhra Pradesh. And the timeline for compliance was March 22 for Unit 1, June 22 for Unit 2, and September 22 for Unit 3. And it means it was a phasing plan based on the resource of the erection agencies or work awarded by the operator. Then this timeline was given. Due to corona and other issues, this timeline was revised. Next slide, please. As per notification of 31st March, there all power plant were categorized in the 3 category. Category A, these are the plants within 10 kilometers of the national capital region or cities having the 1 million plus population. Then timeline for non-retiring unit was December 22, 31st December. And if any operator will declare that I am going to retire this unit, timeline for that unit was also for December 22. Category B, that is 10 kilometer radius of critically polluted area or non-attainment cities which are notified by the Niti Aayog. The list of non-attainment cities being declared by the Niti Aayog. The timeline was up to 31st December 23. And for retiring units, timeline for the unit belongs to category B was notified as December 25. In case of category C, the all power plants which are not belonging to category A and category B, it means the standalone unit, standalone power plants which are neither belong to category A nor belong to B. Timeline for those norms was December 25, and for the unit operating in that area, for the retiring unit, the timeline was also December 25. Next, please. Next, please. Yeah. Then again, timeline was revised due to non-compliance or delay in the construction of FGD and other systems. Then again, MOF came with notification dated 5th September 2022 and recently on 31st January 2025. For the category A power plant, already mentioned that within the 10 kilometer of NCR area or 1 million plus cities. Earlier, for the parameter other than SO2 emission, other than SO2 means NOx, particulate emission, and mercury. Timeline was December 22. And SO2 timeline December 24. Now this timeline is revised to 2027, which is mentioned in dark color. It is as per notification on the 30th January 2025, recent notification. Now this timeline, which for SOx emission control, which was extended up to December 24, is now revised up to December 27. For the retiring unit, earlier it was December 22. Now it's revised for SOx emission, which was 2027. Now it is revised to 2030. But for parameter other than SOx, that is particulate matter, mercury, and NOx, timeline is same. For the category B, now timeline is revised for SOx from December 25 to December 28. And for the units belongs to category C, for parameter other than SOx, December 24. And for SOx, the timeline which was December 26 is now revised to December 29. It means it will be 14 years from the date of notification. In the notification, compliance timeline was given as 2 years. And now this will be applicable for the category C plants in 2029. But in case of our plant where I am working, both FGD, which is controlling the SOX, both are operational. Earlier timeline was 26, and now applicable timeline for our plant is 29. But NTPC proactively installed the FGD system timely, and both FDG system in our units are operational well before the timeline given. And we can say prior to December 24, both units were operational with FGD. It means 5 years prior to the timeline stipulated by MOEF as per notification of 30th January 2025. Next, please. These are the environmental compensation notified in the 31st January 2021 and revised on the 5th September 2022. Earlier, for the delay in the compliance of those norms, for the category A, if delay is 0 to 80 days, 10 paisa per unit generation. In category B, 7 paisa per unit generation, and category C, 5 paisa. If delay is more than 180 days and up to 365 days, this is 1.5 times of the earlier. And if delay is more than 360 days, then delay compensation was 20 paisa for category A, 15 paisa for category C, and 10 paisa for category C. Now this compensation is revised to 20 paisa, 30 paisa, and 40 paisa per unit generation. It means if there is a delay of more than 1 year for all category, irrespective, earlier there was a categorization of category A, B, and C for the compensation. Now there is no categorization. This will be a uniform compensation if there is a delay in the compliance of the new norms. And that is, if delay is more than 1 year, there will be 40 additional paisa to be paid by the operator to the Central Pollution Control Board, or we can say MOEF or regulator, per unit electricity generation. Next, please. This was the stack height requirement earlier. For the unit less than 200 megawatt, this was the formula depending on the quantity of SO2 kg per hour. For the unit less than 500 megawatt, stack height condition was 220 meter. And for the unit 500 megawatt above, the stack height condition was 275 meter. You must have seen the stack height very long in the coal-based power plant if the units are having 500 megawatt and above. Now that is revised under new norms. Next, please. Because that was mainly for dispersion purpose. As per the section 33A, thermal power plants with flue gas desulfurization system. This is the primary condition. If you have installed the FGD, then stack height condition is 100 megawatt and above, minimum 100 meter. And less than 100 megawatt, this is the formula, and Q is the again quantity of SO2 kilogram per hour, and S is the physical height of the in meter that will be calculated. Then we can calculate by this. But in case of NTPC, our all new units are either more than 660 or more than 100 megawatt or 100 megawatt capacity, and that height, minimum height is 100 meter. But NTPC proactively, we are constructing 150 meter height in our all plant having the fluid gas desulfurization system in place. Next, please. These are the new norms for specific water consumption. As I earlier mentioned, there was no limit prior to December 2015. For the unit commissioned prior to 31st December 2016, limit was given as 3.5 liter per unit generation. And for unit commission after 1st January 2016, the original notification it was 2.5, which was revised to 3 liter as earlier discussed by me in the earlier slide. Next, please. Yeah, next, already discussed, is the same. Only this is to show. When these new emission norms were notified, because earlier there was only one parameter which was being regulated and monitored, then NTPC saw that there is challenge or opportunity, and the NTPC awarded 100% flue gas desulfurization system for its all operating units in the country. But there are some operators, either they are in tendering stage or in and that planning stage or feasibility stage, or some are in erection stage, except few units of Tata Power and L&T near Mohali. And these were the notification, and there is different opinion and little bit more. Please scroll up, downward, other way. Please scroll down. Next slide, please. Next, please. Yeah. These are just, please hold. This is the timeline. 2017 was the first timeline, which was divided to 19, then 20, 21, 22, and now we are in 25. There was issue of like COVID and the agency's expansion resource, because earlier there was no agency which was working in the FGD installation for large size coal-based power plant. And again, the cost was also increased like anything, because earlier that cost started from approximately 0.3 crores per megawatt, and which touched up to 0.6 crore when there was more demand of FGD system and more tender were coming in the picture. Next, please. Because this is a demand and supply issue. This is the way forward for NTPC. Basically, as I earlier mentioned, NTPC has already awarded for 68 gigawatt or 68,000 megawatt FGD, and already operational at many stations. This is the little bit older data. Now more than approximately 10,000 megawatt FGD is operational. NOx modification work is already completed, and as I earlier mentioned that the all old ESP were modified by NTPC, and in these are the emission of the known GHG parameter. These are the particulate matter specific emission. In 2019-20, specific emission was 0.31 gram per kilowatt hour. In 2024, it is 0.23, and we are having target to reduce it further by 2032. Our specific emission of particulate matter will be 0.2. In case of, please, in NOx, in 2019-20, the NOx emission was 4.41, and our emission for 2032 is 0.76. And in case of NOx, which was 2.1 gram per kilowatt hour, it will be less than half of its level. Next, please. It's interesting. After the commissioning of FGD and other things, as per Supreme Court expanded definition of the Article 21, that pollution-free environment access to every citizen of India is fundamental right. But as per notification notified on the 31st March 2021, that you can operate your units by paying the environmental compensation. That how much justified that type of approach is there, but that is notified by the MOEF, and every operator has to follow that. And there is a matter of perception as well, as shown in the first picture. Prior to 31st March 2021, there was a discussion. FGD is required or not, it will be beneficial or not, what will happen after FGD. But after 31st March, when the compensation was decided, the scenario is, from one side you can say it's 4, or one side you can say it's 3. One side you can say it is mandatory or it will give benefits or not. Again, there is a discussion going on. There are some committees those are working on FGD, that these new norms were required or not. Let's see what will happen. But right now, time extension of 3 years is given to all power plants, irrespective of the category plant belongs to. Next, please. Next one is the how to decide. Basically, there are some units which have already commissioned the FGD. Those will get the schedule first, or business as usual will work. That both units, either with FGD, which is controlling the SOX, or unit without FGD, which are not controlling the SOX, are not complying because timeline is already extended. Which unit will be preferred for operation? Let's see. It depends on the regulator and the rule makers. Next, please. Next slide, please. Next, please. Earlier were the regulated parameter for the coal-based power plant on the emission was SOX, NOx, particulate, and mercury. Now this carbon, that is not a regulated parameter as per law, but now this is a serious cause of concern due to everybody knows that the greenhouse gases and global warming and the different elevation in the global temperature and the serious concern from that. Let's see what NTPC is doing in that and what is the global scenario. Next, please. This is the capacity and growth of the installed power in India, already discussed in detail. Next, please. I will not go in detail again. Next. Yeah, please. This is the generation, as I mentioned. This black portion is, this is the installed capacity and this is the generation. And still now, even today, that major contribution, approximately more than 70% of the total generation is coming from the coal-based power plant. It means CO2 generation is still exists. Even though there are other options also, solar is increasing like anything. If you will see the installed capacity increase, that yellow portion is increasing like anything. But the generation contribution is not increasing as because the plant load factor and the operational time is during sunlight only. That is a constant. That's why coal is still having the lion's share in the power generation. Next, please. This is the annual CO2 emission in million tons from 2008-9 to 2044-45. This is the CO2 emission of our nation, which was 490 million ton CO2 per year. And now in 2023-24, 1259.9. And up to December 2024, 966, and it will cross 1260 this year, definitely. Next, please. By March 25. Next, please. This is the emission level of different country per capita emission level. European Union, 6.3 metric ton per capita. South Africa, and there are countries like Saudi Arabia, per capita is 16.6. United States, 14.2. Russian Federation, or there are different countries, or China is 8.7. Next, please. Yeah, little bit, please move little above. No, other way, please. Yeah, please. Yeah. Just one. Just. Basically, this is the below global level that color from to India belongs, and the remaining portion in little reddish color, rust color. This is the above global level. It means India still belongs to below global level, and our annual generation is in range of 2.2 metric ton per capita. Next, please. Yeah, this is India is 2.9 as reported in 2023, and this is the per capita generation of CO2 from different countries, and this is the total CO2 generation annually by different countries. China is approximately 11,000 million ton. United States and India 2,441. Next, please. Yeah. This is the per capita, total per capita and historical emission. If you will consider from historical point of view, then from you are considering that industrialization started in somewhere from 1850, and from 1850 to 2022, that gigaton CO2 total and percentage of the total, that China contributed 300 gigaton CO2 and 12% of the total CO2 emitted during this period. United States of America contributed approximately 20%, and at third number we are there, India. That total release is just 83 gigaton and contribution is just 3% of the total. But these days they are highlighting by the total emission annually, that is in the first column, and everybody is saying that India is at third position after US and China. And this is the change. Now these are the initiative taken by the NTPC. NTPC is having their our brighter plan, that by 2032 how much will be the installed capacity and how much we will be having the coal-based power plant, how much will be renewable, how much will be nuclear and hydro. Then we are having the target to go for net zero in our township. Then emission control, DSOX and DNOx system already I discussed. Then NTPC is signatory of the UN Energy Global Compact goals. And we are also creating the carbon sink by plantation of tree, and till date, till March 24, 39 million tree planted by NTPC. And NTPC is also developing a mega eco park at Badarpur S-Dike area. And NTPC is started in 2017 that biomass pellets, made from the agro waste, we are blending with our coal. And NTPC had demonstrated the mixing of up to 10% of the biomass pellets to generate power, and we are replacing the coal by the agro residue based biopellets. And now NTPC is increasing its installed capacity by the supercritical units or ultra supercritical units only, and which is increasing the cycle efficiency. That the first point that is having the cycle efficiency of 38.6% Vindhyachal in year 1999, and now the efficiency improved to 42% in Telangana project, which is commissioned in 2024. And it is on the thumb rule that if there is an increase in the efficiency of 1% in the cycle efficiency, there will be decrease of 2.5% in the CO2 reduction, coal consumption, water consumption, or any other pollution which is caused by the coal-based power plant. There will be a reduction of 2.5% on the basis of thumb rule, and CO2 that is evident and mentioned here. This is the CO2 emission avoided by NTPC by the different steps taken by either by creating carbon sinks or by other means, like depending on the more efficient units. Next, please. These are brighter plan, and we have taken the base year, financial year 2012, and CO2 emission, specific CO2 emission in that year, please hold. It was 860 gram per kilowatt hour, and during last year, the specific emission reduced of NTPC plant generation is 834, and our target is 713 by 2032. This is the total emission, and again we are having targets. Then our non-fossil generation, in 2012 we are not having any non-fossil generation. In 2020, 0.07%, and right now we are having 0.1%, and our target is 37 gigawatt. And the share of supercritical units, as I mentioned, that these are the more efficient plant, and we are targeting for the 5.7 gigawatt by 2032. Same is the case in the specific CO2 emission, and our target in 2032 is 0.7 gram per kilowatt hour. In case of NOx, target is 1. In case of particulate emission, our target is 0.18. Next, please. In case of water, please hold. In 2012, our specific water consumption was 3.81, and which is reduced to 2.68 in 2024, and our target is by 2032 is 2.5 liter, irrespective of the norms stipulated by MOEF, that is 3.5 liter for the older unit. But NTPC is having its own plan, own internal targets. This is the Vision 2032 or our Brighter Plan 2032, in which we will reduce the water consumption, specific water consumption to 2.5 liter per kilowatt hour generation. Then again, tree plantation. In 2020, we have planted 35 million, and we are having target of 47 million tree by 2032. Next, please. This is the detail of plantation. In 2016-17, we planted 10.73 million in one financial year. Means more than 1 crore tree planted by NTPC in that financial year. And annually, now we are planting 10 lakh tree per year or 1 million tree per year. And for next 2 years, we will again do the plantation of 1 million tree per year. Next, please. These are the carbon sink created by NTPC annually, and how much carbon we are sequestering. And this is the avoidance of the emission by different efficient unit and other measures taken by the NTPC. Next, please. This is already mentioned that every 1% rise in the efficiency leads to reduction of 2.5% CO2. Next, please. Now, this is the recent development that NTPC has started that green hydrogen hub at Pudimadka near Visakhapatnam in collaboration with the AP government, and that will be hydrogen hub. And the NTPC Green Energy Limited, a recently listed subsidiary of NTPC, that is creating this facility in the 1200 acre near Visakhapatnam. And in that, we will start hydrogen blending with natural gas, then green methanol production, hydrogen-based energy storage system, then hydrogen mobility project, and the green ammonia project. All these are the projects which will help in the carbon sequestering and conversion of the chemicals from the carbon captured from the flue gas. Next, please. These are the already, just 1 month. In NTPC Vindhyachal station, NTPC is having a 10 ton per day CO2 to methanol plant, and already that commissioning of that plant is in the last stage, and already carbon capturing was started, and now that methanol production is also started few weeks back. And then development of the indigenous catalyst and reactor for CO2 to methanol synthesis. Then one is the agro-based or municipal solid waste-based waste. We are doing gasification and we are converting the municipal waste residue, and we are creating the residue-derived fuel, and we are mixing that with our coal. And again, biomass pellets and torrefied pellets by Indian startup. There are different industries. They are producing the agro-based waste and torrefied waste from the agro and other waste. We are consuming that in our plant. There is a provision by the government of India also for mandatory mixing of the biomass with coal, and NTPC is the flag bearer in that, because NTPC only started the mixing of biomass pellets in its Dadri plant in 2017. Next, please. Then NTPC recently started one work on the CO2 battery at Kudgi, long duration electrical energy storage solution. This is the work in collaboration with one of the collaborator or one of the contractor. That work is started at NTPC Kudgi, one of the plant having the 2400 megawatt, 3 units of 800 megawatt critical units at Kudgi in Karnataka. And this battery of 160 megawatt hour storage. This is an initiative of NTPC broader strategy to diversify its energy portfolio. And basically, this will, based on the electrochemical turbo machinery based system, in which we are not using any high value the material for which NTPC was or any India is depending on the other countries. It functions on the closed Breton thermodynamic cycle using the anhydrous CO2 as the process fluid. The charging and discharging of the electricity occurs by manipulating the physical parameter of CO2 from vapor to liquid state and vice versa. Next, please. This is again already discussed. Next, please. Already discussed. Next, please. Yeah. This is the greenhouse gas emission during last 3 years. In 2021-22, scope 1 emission of greenhouse gases from 841 to 834, it is reduced. And in scope 2, it is little bit increase, and scope 3 also, once there is a increase and then again decline. And NTPC is having its target of 734 gram per kilowatt hour by 2032. Next, please. Then biomass co-firing in coal-based power plant. It was started in 2017 as earlier mentioned, and 10% was demonstrated at Dadri thermal power plant without impacting the safety concern and mechanical performance of the existing mill. And in total million, the biomass used in 2021-22 was 40,000 tons. Then in 22-23, 20,000, and last 23-24, 171,000 ton of biomass was used for the power generation in our coal-based power plant. And now it will increase like anything as mandatory mixing of the that biomass is applicable to all the plant, not only NTPC, for all coal-based power plant it is applicable now. Next, please. These are the benefits of burning of the agriculture waste in the field and using this waste in mixing with the coal and generating the power. Next, please. These are the basically what will the impact. These are the pictures of how these are converted from agro waste to the pellets. These are the different steps which are followed, and different type of pellets are shown here. Next, please. And now, Government of India is having a Samarth portal, Sustainable Agrarian Mission on the use of agri residue in thermal power plant, National Mission on use of biomass in thermal power plants. This is available on the website of this Ministry of Power portal. That is a Samarth mission, under which this made use of this biomass is made mandatory for all the coal-based power plant. Next, please. And it also included that development of the local vendors. And now NTPC is having one joint venture company with Nuclear Power Corporation for the installation of nuclear power plant. And in case of the carbon footprint, that per unit generation specific CO2 emission is only 12 gram CO2 equivalent from its life cycle. If you are generating power from the nuclear power, and the average from coal based is 820, we can see that how much can be reduced by adopting the nuclear power. Next, please. These are the what we can do, you and myself, or any individual, or any citizen of India, or any corporate house, how we can reduce our carbon footprint by transportation, heating and cooling of building, industrial carbon output, electricity generation at office, home, or in our kitchen. Next, please. Next, please. Yeah, if we are having a car or any mobility, that what type of, how much efficient vehicle we are using, which type of car we are using, we have to think, and then we have to opt that we are having a fossil fuel based vehicle, hybrid vehicle, or e-vehicle. Then there are different carbon footprint for all type of transport mode, or the option we are taking, depending on the fuel efficiency and how much CO2 that vehicle is emitting. Next, please. Yeah, this is another example. If there is any strike or road blockage or any stagnant in the vehicle movement, then there definitely everything is having the carbon footprint and how much will be increased. Reducing the time and number of car on the road definitely will reduce the emission. These days, if you must have purchased the vehicle during last 2 years, there is a provision which is mandatory by all the car manufacturer. If you are standing on any red light, vehicle will stop automatically if that vehicle is in neutral status. And if you will put your clutch, you will press the pedal, that vehicle will start automatically. There is no need to go for a push button or use your key to start the vehicle. Only putting your clutch pedal, that will start the vehicle, which was stopped due to the long idling. Next, please. This is the building cooling or heating efficiency. Then we have to use the higher star rated cooling system or heating system if we are using in our residence or offices. Next, please. This is the efficient electricity production. As I mentioned that earlier, what was the efficiency in Vindhyachal, and now in the supercritical and ultra supercritical efficiency is increased from 39 to 44 or 46% we are targeting for ultra supercritical plants, and 1% of efficiency improvement reduces the CO2 emission by 2.5%. Next, please. This is the action which we can take at our office: recycle glass, paper, aluminum, and plastic, recycle paper product. Then turning off your AC while leaving the office, shutting off your computer, install a programmable light timer, or now intelligent lighting is there. If nobody is there in room, light will get switched off automatically. Then programmable thermostat and other things. Then you can reduce your carbon footprint at your office also. Next, please. Then inside home, then we can use high star rated home appliances, replace a regulator, simple lights with LED lighting. Then AC temperature setting should be more than 25 or more. Then clean your filter of your furnace and air conditioner, and install window shading in place of going for another option which is consuming the electricity for the same purpose. Next, please. Then inside the home, use less hot water. Instead of the flow, you can use water in different modes, and you can use warm or less cold water. Then turn off or unplug the appliances while those are not in use. You can avoid use of these vehicles during peak hours. Basically, it is a very important issue because everybody knows that there are some peak demand times, and during that period, if every citizen of India or even in 20% of citizens will take care that these are the peak hours, and if they will avoid the higher electricity consumption appliances during those hours, that will help the reduction in their CO2 carbon footprint, and definitely they will help the environment. Turn down the thermostat on the water heater and wrap your older model with a water heater blanket. Switch to green power. Next, please. Then in kitchen, what we can do is support your local farmer, buy local foods, because transportation of one product from one location to another, everything is having its carbon footprint. Then conserve water in the kitchen around the house, buy fresh foods in place of frozen, because frozen is also consuming, freezing of any material is taking electricity, and that is having its carbon footprint. Just few minutes more, sir. Avoid heavily packaged product and cut down your garbage. Buy organic foods. Bring your own bags in place of using that single-use plastic or plastic made, which are prone either that will go to a co-processor or for burning or for recycling, that will go in place of that. If you will use your bag, definitely that will reduce your carbon footprint. Clean your refrigerator coils and give some breathe. That's definitely that will improve the efficiency of your equipments. Next, please. Then on the road, while driving, while biking, while going to your office, you can go for by carpooling or by public transport. And then while purchasing a new car, you can decide which type of vehicle you will purchase. Then fly less and purchase carbon offset to balance your travels. You can go for a green travels when you are going for any business trip. Then you can cut off your movement at least from your house to airport, in place of using your own vehicles, your official vehicles. Then you can, in place of that, you can take a public transport. Definitely you will help in the cutting of your carbon footprint on your business trips as well. Next, please. Mind your personal footprint and attempt to reduce as discussed in detail. Thank you. Thank you from my side.
Okay. Thank you, Dr. Deya. Now the topic is open for discussion. Participant, you can ask questions.
Hello, Doctor. Good evening.
Good
Thank you
evening.
for your enlightening session. It was really a great session. I have just one question, Doctor.
Yeah.
You spoke about threshold limits, isn't
Yeah.
it? So I just want to know what modern technologies NTPC is using to take care of these thresholds, how they are maintaining it.
Basically, I use the word threshold in case of when any chemical or any constituents of environment will be a pollutant.
Okay, but I want to understand.
Yeah, basically that threshold depends on the risk involved while interface of that chemical or that constituents with any species.
I understood, Doctor. But my question is, so what NTPC is doing, any technical or technological intervention to limit to this threshold from their work perspective?
Basically, threshold depends on the chemical nature of that constituents or physical, radiological or biological nature of that constituents. NTPC is doing work to control emissions at its source and reducing the contribution in the environment from NTPC's activity or operation of the NTPC plants. Because no one can change the chemical nature or the constituents of that any chemical species or biological or physical.
Yeah, I understand, but I just quickly want to understand over the period of time how technology has helped NTPC to reduce that emission. I mean, from
Yeah,
a
as I mentioned in my slides, that how the specific emission of particulate reduced from 0.48 gram per unit generation to rightly 0.23, and we are having target of 0.17 by 2032. In case of SO2, NTPC installed FGD at all its stations. NTPC has gone for the zero liquid discharge, irrespective of either that is legally applicable on the NTPC or not. For the unit commissioned prior to 2000, where discharges are allowed, NTPC proactively has adopted zero liquid discharge approach, and there is no discharge from even from our old station also.
Okay, got you. Thank you, doctor. Thank you. Have a wonderful evening ahead. Bye-bye.
Yeah, thank you.
Any other questions from the participants, please?
Dr. Ansu, please. There is some raised hand message.
Yes, Dr. Ansu.
Good evening, sir. With the help of biofuel, how can we generate the electricity like parali?
Yeah, madam. Basically, that Samarth portal that was started only for that parali issue. Basically, not only parali, there are some other agro-based residue as well, which are not of use of for fodder to animals or other. And the farmers are burning those. Now there are small startups, small plants. They are converting those biomass in form of pellets, normal pellets, by putting mixing some additives, and even without additive, they are with high pressure, they are converting them as a pellets, and those pellets are being mixed with coal. And NTPC has demonstrated voluntarily in 2017 that these biomass pellets can co-fired with coal up to 10% without compromising the safety and the mechanical health of the system. If you will replace 10%, then we will avoid 10% CO2 emission from fossil fuel. And farmer will get benefit. In one of the slide I mentioned, because due to time constraint, I didn't cover all points. Farmer will get money in place of burning the waste in their fields, which is also affecting the soil health of the field.
Okay, sir. Thank you so much, sir, for nice information.
Yeah, NTPC burned more than 174,000 ton last year during last financial year. And now it is mandatory that all power plant has to mix 7.5% of biomass in the coal. Let's see how much we will succeed, because supply is a constant. Basically, people are saying that ample biomass is available in the field, but while purchasing, that quantity is also a concern, and there is a difference. That location where biomass is available and the location power plant are being operated, that distance is having also a carbon footprint for transportation the biomass from one location to another.
Okay.
Any other questions from the participants, please? Okay, thank you, sir.
Thank you, sir. Sorry for the technical glitch. It was not
an issue, sir. Now I would like to express my deep sense of gratitude for your outstanding contribution to the field of environmental management in coal-based thermal power plants in India. And really, your in-depth research and data analysis have significantly advanced our understanding of the environmental challenges associated with the coal-based thermal power plants for power generation. And by highlighting the effective environmental management practices, you have paved the way for more sustainable options and reduce ecological impacts. And your in-depth analysis balancing energy needs with environmental stewardship is truly commendable. Thank you for your invaluable insights and leadership in promoting the environmental practices within this critical sector. Thank you, sir.
Thank you, sir. Thanks for giving me the opportunity. Thank you.
Thank you, sir. Okay, participant, tomorrow we'll meet by 6 o'clock and we will finish by 9 p.m. Okay, thank you all for your cooperation.